Okay, welcome to the third day of the Microscopic Landscape Workshop. For today, we organized three sessions. The first of is going to be a focus more in a working session. We would like to have a more like a fast exercise to encourage you to jump into a more creative process. With Rebecca, as we said yesterday, we were reflecting that is having a lot of information for all of you. It's quite rich, and also we want to give you time to develop further your ideas. So we will come back to a very short exercise that we want to assign to you to do in this free time that we're gonna allocate in this first hour, and then we will come back at 11 with one more lecture from some of your colleagues in the from the IAC, the Institute of Advanced Architecture of Catalonia. The second example, the second lecture is very much oriented in the same direction that we use the word that you have been seeing the previous day. Shuton is here with us now, yes. And the idea is to be inspired by that and to jump into your topics, especially step by step with the tools that we have been providing. So, and start to open a conversation about the topics. Yesterday was quite exciting to see the first steps of Russia and have conversations that move between conceptual issues, methodological issues, but also create about the tools, how to use the tools or enhance the use of the tools toward the production of the research. The lecture at 11 will be focused also in the workshop of our previous seminar in molecular landscapes. And then at 12, we will have another hour where we like to again run a very fast exercise. The afternoon is quite rich, quite exciting. After lunch, we will have another lecture from other group for the last group. And at 2:30, so we start at 2, and at 2:30, we will have this from 2:30 to 5, we will have the session with Tomas Mena. When we will introduce topics about growing patterns and growing systems. He have prepared a very interesting sessions in Grasshopper, very straightforward. He will upload the material also in the afternoon to you to play with some algorithm, and the ones that are more advanced or already know the tools, you will be able to create your own growing pattern. The important things of these steps is that the growing pattern could be used for the session of tomorrow, that it will be based on AI image generation, very much mid-journey, but also Aram and Irina prepare other exciting tools like Crea and in terms of image generation. And we will have also another session in the afternoon with Aram based on Blender, or how to import topographies to Blender and make other, or try with other forms of representation, right? So it's allowed to take, but please just jump into that and try new issues, try the tools. We were thinking that one nice exercise that we can initiate this session is to allow you to have two different directions. So one of them is to localize the site of investigation and try to define an area and run the exercise of the sequence of image of the territorial evolution. And that at least it will encourage you guys to see the area that you are working with and see the progression of and the alterations that happen in the landscape. And that is a very straightforward ways to initiate our talking. So if you are not able still to make the video, at least try to drop your images in a Miro board, could be easy, or in a document, in a PDF document, and we can see it in advance. We see the progression and try to find patterns that show us a form of alteration in the landscape. The second point that we were thinking that it could be exciting is the historical part that we were suggesting you to have a look and make a very short or wide investigation about the topics, about how the historical issues about the site of investigation. If you think that you can find some clue or hints about what kind of forms of exploitations or practice happening in these areas. These are very straightforward point. You have in the documents that Rebecca upload the coordinates, so you can really identify very fast the area, go through that, run the sequence of historical images, type and investigate in ChatGPT or Google the areas to find some historical information. You can also find some historical maps to see that, and the ones of you that are more familiarized with the tools of the QGIS can also turn on and turn off some layers in the package that Hana provide to you. All right, so I think there are many ways to enter in the exercise, but at least we are asking to jump into one of these tools and come back to us at the end of the session with at least one of these procedures. There is one more suggestion to initiate today, is to start to thinking how to prompt the image generation, especially because the prompt or the way that we are encouraging you to think in the prompt is not just a text that provide information for the software, but instead also to give you some hints about the narrative that you are creating, or to give you some kind of a general vision of what you have in mind. Yesterday we were when Rasha was sharing his work, we were thinking about what is the possible narrative that could be embedded in your investigation, and it's just to pick up one of these topics and push it forward. And we like to encourage you to develop a paragraph, maybe an abstract of, I don't know, between 200 words or 200, 300 words, maybe not necessarily to be so big, in which you can describe or mention the topic of the study and fit the algorithm with specific information, especially like talking about how the area has been exploiting. Let's say like I describe some in the text, some couple of lines that talk about the antecedents of what happened there, then a couple of other lines that describe the type of organism that you are working with. Especially have a look of the document that we upload that is called Nordic Arctic Atlas of Territorial Violence and Environmental Injustice. It's a Word document that we provide you with specific names of the species that we investigate in the Arctic. You can actually include it in your prompt, and with a more specific approach. And then, of course, finalize your prompt with the vision, how you envision this ecological future based on this process of regeneration. Rebecca and me upload many more images that we found from the first collection of samples in the Arctic region. They are very exciting images. Some of them are really, really interesting patterns, interesting. So there are also some videos that are interesting to see. So please take one of them, put it in, drop it in your either in your Miro board or in your PDF document. Put it beside the territorial evolution. Try to type some text and describe some narrative around the ideas, the first ideas that you have, and let's come back to us. We will make a round, a first round at the end of this hour, and second round at the end of the morning. All right, so we will go step by step with each of you to see your first idea. So as we said, guys, there is no pressure, so just jump. Try to put together something in a document that you can share with us, all right? And we initiate our conversation today. That will be exciting to them after lunch, jump into these new tools that Tomas will introduce, and that will give you also more opportunities to them narrow down your topic of investigation and push it forward to tomorrow in the image generation. Yes, Rebecca. Some other words, Rebecca? No, no, perfect. Yeah, is it clear where we going? We want to hear from you guys. Can we hear from you some comments about that? Are we in the same? We are in the same mood, same taste? Is it clear the instruction?
Yeah.
I joined a little bit late, so can I repeat to be sure what I'm going to do? So we will use one of the softwares that we learned yesterday, QGIS or Google Maps Pro. We will we will use the coordinates that you provide to find the locations and make our research on the map about the topic we chose in the first year, the topic we want to choose. Then we take the photos of the historical image like yesterday and use these photos and the informations that we can find on the internet or ChatGPT, whatever, that like their historical background, their flora, fauna information, that type of informations of the area. Then use both of them to create generative image. Also a small abstract, but I don't get it what the abstract should be about.
Perfect. Adrian, I think just to say that is the first part of your description is exactly where we're going, no? And if you feel that you can start with the image generations, please jump into that. Some of you already use the tools, and tomorrow we will have more specific introduction to some tools. But I think that it's exactly as you described. The paragraph is about the possible prompt. No, is to have to start to configure the narrative, the script that you develop for your research, right? So
I think the point also right now is to understand a little bit the background of the site that you are investigating. So that is what when we say an abstract, it's a kind of formulating the issue or what is the case that you are looking at more or less, and to get a kind of basic understanding of that, because then it's easier to work from that also, and then to use the tools that you were provided yesterday. That is probably the main
exactly
lines.
Exactly, so perfect.
Thank you.
You know,
then you can do it all. You don't need to do all of those things now within half an hour or what it is, but as a way to start, that you can take these tracks forward.
Perfect. It's a kickstarting, and I will always like to think in this, again, in the idea of a synopsis, no? The synopsis of a movie, for instance, no? That you can maybe an abstract is a little bit more complicated piece of text, but maybe imagine, guys, that it's a kind of a synopsis of what you are looking for. And you can type specifically, well, these places have been affected by these industries. The structures initiate 100 years ago with extraction of certain minerals. The species collected are these and these. That type of fungi. that growing in that sense, and you can also paste some of the information of these species, and then the speculative visions from post-human scenarios or kind of a vision for the future that you want to portray. And that give you some small paragraph that is something in between a synopsis, a script, or an abstract, no? Right, but allow you to combine all the materials together, the historical approach, the evolution of the sites, what kind of species that have been thriving there, and what is the kind of a performance or that these species have, if is it that they sequestrate carbon, or if it's that they are cleaning the toxicities, or what kind of a mutualist or a specific behavior that you envision that happen. If you see that the article of Bratton is moving between that, no, he make a very short context of what happened with these U.S. installations after the war. Then he described a specific situation where a species, non-endemic species, thrive and create some sort of an intriguing, no, as it was coming before, intriguing us in the way that why this really happened, and then describe a little bit the function of the operative aspect of that, saying how those species collaborate with different forms of labor and creating such an amazing biotopes of coexistence. And then he triggered the future, saying, well, but what will happen in the future is maybe that we are actually the robots for the future insects, no? and stuff like that. No, okay, so this is very much the way. So one of the good things for that, as we were saying yesterday, we were discussing about the method, guys. If you are using Miro, drop the things in the middle, as we were seeing in the case of Russia. This is a very good way to go. So just put the images of the site evolution with the tools yesterday. If you layer some other information, data geographically or geodata from sites in QGIS, put it also there. Drop up some referential images that you find Googling. Paste the text of your possible prompt. Paste the image that you select from the samples that we upload, and that give us some kind of a panorama, so like a map of the investigation, and to discuss further. All right, is it clear?
Yes, thank you so much.
All right.
Yes. Okay, do you want us to create breakout room for you?
Yes, are you working in, yes, it's in the groups, are you working together or are you working separately, right? Guys, are you working individually? No, we want to know that, so.
Would you like to have a room where you can discuss with each other separately?
Yes, please. If possible, we have a room to just discuss the work together.
Yes.
All right.
Thank you.
Okay, perfect. So we will coming back, guys, at 11. So take this half an hour to just drop some information. We coming back at 11 with the half an hour lecture, the short lecture talk of Shudan and his colleagues. And then we keep going at 11:30 until 1 in this session. Okay, we keep going with the groups, with the breakout rooms, and we have a final discussion at the end of the morning. All right, but push it forward. We ask you to be very creative, very free. Remember that we are making imaginative investigation, is creative thinking, abstract thinking. Allow your imaginations and your first try. So work with your speculative vision. So it's very important to let your abstract thinking to operate in this way. There's nothing that it could be incorrect or correct. So it's just to provoke by combining and intersecting all these different tools and and we will coming back and help you to reorganize your research. All right, so go for it. See you very soon. So we're gonna make the groups.
And then at 11 again is the the lecture. Just so we know.
There is any question? Just please drop it here or open your mic. Right, we are pending of you.
Mhm.
Go through the video. Okay. All right, so I would suggest that you can go through the video. I'll also play the video here as well. Just a second. Yeah. Is it visible?
Yes,
Yes.
clear.
Yeah. Is it in full screen or? Yeah. All right. Yeah, so I hope everyone was able to see it. Was it okay? Was it audible? Okay. So we'll just share the presentation from this forward. So we have made a video and a presentation, and we were like 6 of us in a group, and we'll just share the presentation right now. So is it visible? Is everyone able to see it?
Perfect. Perfect, Haiek. Yes.
All right. So as part of our seminar, which we had in Haiek last time, Alejandro and Rebecca was part of this amazing seminar which they had taken for us. And they were given like, I think my colleagues must have actually like given everyone a small introduction to how it was done. Like we were like 5 groups, and like we were split into like 5 groups, and there was like 6 or 7 of us in each group. Some groups had 3, and we were given a small introduction in such a way that we were supposed to get samples from different sites and map its origin and how it was like what is the history to the environment, and what was the history to microorganisms and everything over there. So we chose this park. It's called Ciudadela Park. It's in Barcelona. It's kind of in the heart of the city, and we were able to like get through a lot of what do you say species, and like very protected species, like there's actually like these very famous parrots which are actually very famous there, and how they kind of influence the ecosystem also there. So for us, since you have seen the video, you can see that there was actually a lot of samples which was moving under the microscope. And by the way, those microscopes were not actually, well, those visions were not actually moving. They were like made to move a little bit. Some of them were moving, but to exaggerate it a little bit, we were using a different AI for that. We were using Runway for that. So we'll get into the technicalities of it. But in the beginning, what we started off was, we collected samples of sorry. Yeah, so this is the site where we were, and these are the locations. What you see in reds are the locations where we got the samples from, and we got a lot of samples. Where there was, granules of small sand. We had algae. We had these, sand which was actually like, mixed with the feathers of the birds, which was already there, and tree barks, and we also had a very small sample from, the from a like from an ant colony. Um, it was not a very dense one because we were not able to like find a lot of what do you say ants, and we were like able to find like 2 or 3 of it, but we were able to still like trying to like map how these organisms and how they were like influencing the molecular landscapes of it. So just a short history of Sidullah Park. It was made as a what do you say like a small pavilion. It was like a universal exhibition for different kind of plants and different kind of like flora and faunas back in 1881. And then slowly it turned into a small park, and like people started using it, for recreational purposes. And there was lakes, and there was small like what is installations and everything, which kind of helped us to find diverse kind of samples. And we were also mapping the kind of birds that were there, because the kind of species that is in that particular environment also influences the kind of reaction that happens along with what do you say the species which we took, the samples which we took, because these were all like different parts of the park, and even though it was like a very considerably small area, when compared to the city, it kind of like breeds a lot of life in it, and there is a lot of varieties and diversity in that. So because of that, we were able to like get a different influences in the kind of speech in the kind of samples we got. So just like we told, we got the tree trunk samples, which was much more damp. And since there was no access to sunlight, we could also like find like very humid, like like very moistured samples in that. This is what you guys saw in the map, in the video where we had this, zoomed in of this, and we're trying to make it move and make it more interactive. And over here, where like, so this is one of the places where there was a lot of birds, and the protected parrots were all here, and people used to come over here, and they like pour in, they actually drop in food items and everything. So their interaction with the surroundings also help us find much more what do you say, mixed, kind of like totally unrelated, and we can find very like not so connected samples coming in, like like small like like itty bitties, like molecules that is actually like very small with each other, and like they're totally disconnected, but you still like find some kind of relation. And once you like find like the history of it, like you get people come here, they give food, and there's birds who come and they take these food, and then they have these feathers and everything, like that's actually like all around the place. So because of that, the sample was very what do you say, diverse within itself. Yeah, that's how it looks like under the microscope. And we were able to like get algae as well from these samples, and trying to understand how it was, like, because sometimes we're also confused like whether this with breadcrumbs, wet breadcrumbs, like me and like Shutang and like a couple of us, we were right there. And when we were trying to get these samples, it was looking like very like it was like there was a lot of things underneath it, and we were hoping that it was algae, and thankfully yes, it was algae under the microscope. And we were able to like find some dry samples as well, like from the tree barks, and from the ant colony we were talking about before. And these samples kind of helped us understand how like over time this place was evolving, and how there was a lot of different species that used to come and go, and how these were like involved, like influencing the environment over there. So what you see in the video was basically like beginning and the end, and how we go back again from molecular level. We actually take these samples, and how we like find like living organisms like staying within them, and how we are all yeah. So this was supposed to be a VR thing, but sorry. Mm, sorry about that. Okay, so this video would have made much more sense if it was on the VR. So what we were doing ultimately was, collecting these samples and understanding the history and the evolvement, and how it was evolved from, like from back and forth, and try to understand like how, like at a molecular landscape, how more or less that is something that we can take up from nature, and how we can, like get to learn a lot of things from nature, and how can we use that landscapes in real life, as in like in human scale, and how it is also same at a celestial scale. So that's what we were taking, like from a molecular landscape, then we were taking it from a human scale, and then we were taking it to a celestial scale, and how we kind of bind back everything together. So that was more or less like like our take from the entire seminar. And like we were able to like like use a lot of platforms in like like giving us meaning to what we wanted to like visualize. And what you see over here particularly is using stable diffusion, and this was a setup that we were using for VR. And yeah, you can see how the speed is up, and like so these help like in like visualizing how you want to like show up your case, and how you want to like present it to people. And yeah, that's more or less. Shutong, you want to add something?
Thanks. That's great. So at the beginning, our concept is like we want to make a bridge or find the connection of the real world and with the molecular world. And so we want to find, maybe they also have the community, they also have just like our society. So that's the beginning concept, and then we go to the site to some different samples to to realize what that world is like. So you can see that VR part is, you can imagine that VR part is really interesting. So you can imagine you are the ant, you are one of the molecular part, because we use the AI tools to translate that what we saw in microscope, and use AI, use VR, and use the AI tools like the distributed vision to translate it, to help us understand what looks like. So, and the VR part, we are welcome everyone to wear that VR glasses. In the glasses, you can imagine you are the ant, and you are the part of that beautiful world to realize what happens near around you. So that's really interesting part for that. Yeah, that's true. Yeah, and we also, maybe I don't know what you guys think, but maybe we can chat later about our video. So in our video, we are thinking about, maybe it's like a loop. In the end, you can see that we zoom out from the microscope to the real world, and it's like to the point, to the real world. So I think maybe it's like a loop, and the world is like no end, no start, and you can find, maybe we are not, our human is not the biggest one and not the smallest one, so always have something bigger than us, smaller than us. So I think that's the amazing world with life. So that's our concept, and it's truly help us for not only for the architecture and for our life, to think it totally different view to think about that. So yeah, that's result in that one we call. Thanks.
Bravo, fantastic, guys. Such a great piece of work. I'm really happy to see it again, and to see you both presenting with so much excitement the work you produced together with the rest of the group, that unfortunately we don't have it here, but there was amazing week, amazing energy, and the more that I see and the more that I enjoy this fantastic piece of work, piece of research. I can say that there are, you, Syed and Shuton, described quite well, and I like your last comment. Yeah, we look kind of blue here, kind of, we are melting here in the blue, Rebecca and me. But I want to highlight two things of this research that is very connected with what we are doing here. So especially, in the case of our previous seminar, in the landscape series, was more related with the molecular aspect, and especially the context of Barcelona, no? And to see what really happened with such an interesting city, and to look into the issues that probably nobody observed, or not so few people observed, especially the invisible world that from tourists and from people that visit the city or living in the city even is not easy to recognize. But then the fascinating dimensions that all this process of urbanizations have been creating. No? That is there's still nature popping up there in this such a robust and exciting city. No? So and then there's two things that we always discuss, and I remember that in our first conversation always this idea that find some sort of another sense of community within the city, and that it was a very initial point that was fascinating for this group to see that there are other forms of community that happen. They are invisible to our eyes, but we coexist with them, and those was very much the first before to take samples in the city. I remember the conversation with all of you guys saying, okay, but we want to investigate other forms of communities, that there are the invisible forms of communities that happen in microscopic and in molecular levels. So then when you went out to see the city and explore the city, you found these fantastic chopping trees that inside were having such a fascinating forms of cooperation and coexistence. So, and then you're scanning and bring it back into the laboratories, and finally you find a way to show to the public or make an experience that make other realize that kind of a collective life or communal life that happen in molecular levels. And that is, I think, there was one of the exciting point of your research. And the second level, I would say that is every time that I see the video, I remember the power of the and this kind of a zoom out relation with the scales, and zoom out and zoom in relation for the aims. But in your case, it was the translation or the transitions between scales don't happen in a scalar way. So by going out and going in, but it happened simultaneous. You find a way to make transitions between planetary visions and molecular visions, and that is a good way to understand the correlations across the scales and the way that we actually are completely interconnected. So these planetary entanglements at the same level of the molecular entanglement, and the forms to make intersections between the scales through this fascinating video that you produce. Yeah, very. Yeah.
I have very much the same comments that you. I think it's the video is so exciting, and I think that the title and the video are really like the Odysseus of it's perfect of the ant. And that is really nice to you really make us change the scope, kind of. You give us the perspective of the ant instead, which is, like you say, a way for us to emphasize with like hidden or these invisible communities, which is very, very interesting, or what we aim for, no? And this augmented or the exaggeration is also a way to kind of visibilize also what we're talking about, like frequencies and things that and to understand the interconnections and the interrelations in time and in scale between species, between us and between the microscopic the biology on a microscopic level. Yeah, very, 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 very interesting, very fun.
Very exciting. Thank you for jumping in and share the work with our students, and also for, well, some of you that have been also participating, Shuton, that you subscribe again to this version of the workshop. So we are excited to keep engaging with all of you. And I now open the mic, please, to the rest of the students to share your thoughts, ask questions to Shuton and Syed. Please, the mic is open. Share your thoughts. If there is any question for Shuton and Syed.
I mean, it was confusing for the jurors, so I'm pretty sure the students might have some questions for sure.
I don't have any question, but I think your work was really great, and I really enjoyed too that the just have the idea that what is going on, the as you mentioned, the invisible connections between the in molecular levels, and it was really innovative and such a wow.
Thank you.
Thank you.
Thank you, Aram. Thank you so much.
Thank you.
Yeah.
Yeah. Can I say, because I heard about the first day of our workshop, and somebody's concept is uh, the time, and talking about the time, what will be look like the time and in the molecular work. So what the molecular species think about time. So that's also, for me, that's a very interesting part of the. So we can imagine everything around us. Okay. Look, it's my voice. Sorry, maybe
We lost you a little bit,
so my
Shuto,
voice.
yes. But you was mentioning about the time in the molecular world, right?
Okay. So my voice is not clearly. Sorry. Okay. So yeah, I'm thinking about that. If we think about everything around us, about time, about everything, also in that book, you share with us that the book talk about the laws. So how about in that molecular part? How about like the ants, like the other species to make our law, make our I remember that in the book, a part we talk about the politics. It's talking about every design just based on our politics. But how about maybe if like the molecular species to think about to the human society, the politics, the laws. I think maybe that's a totally different world. If we think about in that view, maybe that's I don't know, maybe a different world, maybe a beautiful world, maybe a totally awful world. I don't know, but it's pretty interesting for me.
Yeah, it was mentioned the book of the introduction of Terraforma book. I think we upload that too, no, Rebe, no? Yes. This is the introduction by Bruno Latour, no? And this book's Terraforma is quite exciting, guys, to see further for the one of you that can have we upload some of the chapters that we found free there. The introduction of Bruno Latour is fantastic, same as the first part of the book introduced by Alexandre Touauti, and one of the Terraforma member. And it's true that they talk about a map of living things, no? That every time that we make mapping or cartographies, we're trying to paralyze the world into a single forms of representation. While what we know is that all these living things are moving, interacting with others, creating different life cycles, and not just transforming themselves, but also transform the material that is around, and also modifying the space and the geography. So that is quite exciting to see that perspective. Not the world paralyzed by map as a forms of control, but the maps as a form, or these forms of representation as a way to experience new dimensions of nature. And that is fascinating. I like that also Shuto mentioned the idea of time, the time in the molecular world. That is not our time, as we were explaining in the previous sessions. That is not maybe based on hours, days, months, but there is a time in the geological and biological world that we still perhaps not have the instruments to represent or make it visible or make it understandable for others. And I think that I know that very much your intentions in this work was trying to see that, not to the videos show that another dimension of time or another way to understand this different dimension of nature. But have a look at that. So I always envision that the ways that these tools can end up is to give us a hint of the natural world in constant movements, constant transformation, when we can see life cycles, periodicities, rhythmical frequencies, intervals, and that some sort of a representation that include time and not just trying to paralyze the world in a single piece or in a single graphic piece. So I think it's very relevant, for the workshop that we are doing now, so we are running now, and to try to see if your ideas, not just, let's say that the idea of to look into the existing or historical maps is a way to go to the past, and then the idea to intersect one to another is the idea to overlap dimension of natures that are not visible in a single view, or the idea to put a stop motion and a sequence of images in Google Earth is the idea to accelerate time and try to see patterns of deformations or patterns of growings across time, right? So all of these, if you see now, are tools to give us other dimensions in interpretation of nature, right? That is what we are trying to do here. So thank you so much, guys, again, for your presentation.
Thank you.
Yes.
It was great.
Thank you so much. Thank you for the opportunity. All the best, guys.
All the best.
All the best.
See you.
See you soon.
Thank
Yes.
you. See you. Bye-bye.
Bye.
And yes, we have a question from
We do?
Nastaran, right? So
Yeah, please.
you have a doubt, or Agi, you want to say something? Yes, I'm sorry. Yeah.
Thank you. It is valuable to know the natural species that try to collect and know the microorganisms. The presentation was interesting, and actually it helps us to understand the objectives of the course, actually. And here's the question: have you taken the organisms pictures? I mean, with the special equipment and use them to develop your, for example, artificial exports. I mean, share this image with artificial intelligence, and I want to know if artificial intelligence feed like Stable Fusion was laboratory images you get or not. I like to know about the process of image generation, if it is possible actually right now. And the second question is, let's next time I ask the second question.
Yeah. So the entire process was we had so initially we had taken samples and we had kept in small plastic bags and everything, and we had those contained in different what do you say, we had a small mood board which we were asked to make, and we were we labeled it, we labeled it, and everything was there. And then using a microscope, under the microscope and the software that is based on the microscope, we just took snippets of it. And so we used that photograph to use in Stable Diffusion. We used that image in Stable Diffusion. Some images we used it with with prompt, and some images we just kept it as it is and asked it to move. But I would say the most what do you say, ideal way and quickest way to do is I'm just sharing a link in the chat. If you guys can use it. It's called Runway ML. It's based on credits. I mean, you can actually make multiple images move. You just need to upload the image that you want, and then it'll make you move it depending on the templates that is already there. It's very simple. I mean, it's not, it's a no-brainer. It's something which we can, very quickly grasp to. And for the VR thing, which we made, we actually made some images from Midjourney, and we then use that image in Stable Diffusion to make a series of image from that. Because Midjourney right now has not reached a point where in Stable Diffusion, where you can control the same image and make variations from that image. And Midjourney has not reached that yet. You can make something which is more or less similar to it, but not exactly the same thing, and make variations like from that, like from a growth pattern. Like you cannot make series out of it which looks very similar, which looks exactly like like coming from that image. But in Midjourney it's more, but in Stable Diffusion you can actually like control that. So for the VR thing, I would suggest generate an image from any AI tool. Not me just Midjourney, it can be anything from Runway or Polygon or anything. And then you can use that in Stable Diffusion to like make series of images out of that. And for particles to move and to make particular images to move, just one image, you can use the link that I've shared. It's called Runway. It's an amazing piece of software.
Yeah, thank you.
Yeah.
And tomorrow also we will have a session of this kind of translation of images and information through AI, different AI tools. So this will also be the focus tomorrow so you will get more help with this tomorrow.
Interesting.
Yeah, and the other point, Agil, that we said that is because our previous seminar was in physical and it was not online. Of course, we brought microscopic, electronic microscopic, and then we brought Petri dishes and as an mysteries like
we kind of made a small laboratory
yeah, we
in the
make a
studio.
small laboratory there in IAC, and it was quite exciting, to go there and collect samples and put in a microscope. But please use all the samples that we provide you in the folders, okay? Own it and use it and push it forward from that, okay? There are a lot of information that we upload. Have a look again of this folder. Rebecca and me put a couple of fill the files, the folders with different files that we found from our first collection from the Arctic. They are specific samples from the site that you are investigating. Okay, so feel free to use it, especially for the session tomorrow.
Thank you. Yeah, it must have been an interesting experience actually. Thank you.
Okay, so thank you so much. All right, so I know that we have some comments before from you, Nastaran, that you want to ask some questions. From you have pending questions to us that we say that we can.
Yes.
Yes.
My question was that can we, we're visualizing the future of the area that we're just working on, and can we just make a solution for it to, how the future of the site could be if we just don't do not disrupt it, and what it could be if we disrupt it, into different conditions.
That's a good idea. That's a very good idea. I think yes, sometimes the future is not so optimistic, or sometimes, and that is, I think it's a great point. Or sometimes we learn more once we see the fragility of the natural environment. So I think we work pretty well to create scenarios. And some scenarios are contradictory, some based on contradictions, some scenarios are based on different hypotheses. I like this point of view. So very nice. So just formulate your hypothesis, formulate the different scenarios, and the kind of correlation that you want to have between them. No, either if they are opposite, or they are different point of view, or which are the variables that you want to put in contradiction.
Thank you.
Thank you, Nasran. It was a good question and recall me a question. Is it possible to ask another question, Master, or that's another time?
Yes, please, Agil, go for it.
Yeah, just is it possible to share my screen about
Of course.
question? Yeah,
Go for it, of course, yes.
yeah. Here is it visible for us?
Not yet. Now.
Now, yes. Okay.
Yes. Okay. Yeah. I also have a question to the professor. Sometime the destruction of organic life will risk the destruction of, I mean, organic life of human in the past. Okay. Will risk the destruction of microorganism. Yeah. For example, here in this site, after the earthquake, the village is destroyed. I think 60 years ago. Okay, and with the departure of human, the life of microorganism is also affected. Here is a question. I mean, it is probably modern life that has compromised the microorganism. For example, after the earthquake, all of this green area disappeared, for example, you know. And I think sometimes being a human being is more important, especially historical, I mean, in the past. And I would like to know about the destruction is related to modern human, or just modern human, or it is related to, as well as, for example, past generation.
I think it's a super great point also, Aguilén. Of course, I think we can move in time as you consider, and please feel free to investigate further this idea of more moving to the past and the future, see previous events that could trigger the transformation of the landscape. I think it's great. And, but where are we now? So where is this area?
Yeah, it is located in Iran. Iran is a place destroyed because of an earthquake, completely destroyed.
Oh, I think it's a super good case of a study. I really like it. So we imagine that the course, so in order to provide you guys all the skills of investigation, one of the reasons that we carry on the idea of the Arctic region is because we can provide you with these samples. I think that this is very nice that you try with other areas, especially because and you can also include it as a part of your research, but give it a chance to see if you can find the same topic around the Arctic in order to use the samples that we provide, and you can then use the session of tomorrow, which is very much based on these microscopic words. Unfortunately, I mean, if we can have sample from this site of investigation that you are analyzing now, it would be fantastic, but maybe it could be difficult for you. So, but maybe I can suggest that use these examples as a way to introduce your topic, and then ping pong and make correlations with some of the Arctic site that you selected in order to use the microscopic samples. Okay, is it okay for you, this?
Thank you very much. But it might be a little hard to, find microorganism by, laboratory ways. I have not any experience to, follow microorganisms and reach out to them.
Yeah, I think that's the reason that I said that just take the topic of the idea of a previous event and try to go to the site of investigation that we assign and try to see if you can find a previous disrupted event but use the samples that we provide for the next session. All right, so you don't need to have that experience. You can just use some of the material that we provide for the future steps. Okay, is it clear that?
Thank you very much.
All right.
Okay, I have opened the rooms, so if you want to, we put some instructions in the chat before. I don't know if everybody can see it. I can repost it. Now it's time for you if you want to just keep exploring these things.
Yes, we can see each other, and maybe a quarter to 1 or 20 to 1, something is it okay in 45 minutes? Claire? And we release it, and yes, so let's see each other a quarter to 1, guys, here, and we make a short round to see to show a little bit your first inquiries. All right, so follow please the instruction, jump into the topics strongly, without doubts, and try some of the tools that we provide. All right, so we divide you again in the groups. We open the Zoom, the rooms,
It's open.
and we see each other at a quarter to 1 again. Is there any other question just before to leave you guys? Some doubts? Not at all?
Otherwise, we will be here, so you can
Exactly.
you can shout and we will come.
Perfect. All right. Enjoy it.
Thank you.
Thank you, Syed. Again, thank you, Shutam.
Clearly over the time, getting more defined, I guess. Yeah.
This part I want to draw.
Uh,
It's very long one. I mean, it's going all the vertical way down there.
yeah. Yeah, and it's very close to the river, as you can see. And yeah. Maybe you should explain a little bit about the articles. Yeah.
Sure.
Or
Okay, so like we were looking first, try to, let's say, gather information about Harats, because it's very certain specific small location on in the North Sweden. If I'm wrong, please correct me. Northern Sweden, and like with they're also famous with their tree houses. So we can safely say that there are, even though it's a bit small, there are that village and there are some tourist attraction points. So it's not that isolated area, even though at least for me, it seems like a bit isolated at the first. And with the power line, there are different, let's say, effects on the habitats. Firstly in negative, after in the positive way, as I understand. because like the first that before the power line or the first times of the power line, as I get there are these negative impacts on the environment and the surroundings because they are like reducing in the organic term area, organic agriculture areas, farming areas, not farming but agriculture, I think, and the other
Fishing.
problems, fishing, yeah. But then with the regular clearing, that regular, let's say giving importance of to that area, that microclimate areas occurred, and its effect it creates very essential living like habitats for some butterflies, butterfly types. And since it's a kind of isolated area, not because of the habitats, but that tunnels in somehow create their own isolated areas, and provide more secure and safe environments for the butterflies. So there are some couple endangered butterflies, and also some flora find themselves a place to live in more securely. And interestingly, for example, from butterflies, I read it in this article. I didn't edit yet the highlight points. It allowed butterfly to grow bigger than their normal size because there are no more predators, or there are more safe spots for them. Same for some grassland habitats as well. It's from my research. Also, I will get more detail that I didn't read in detail yet, but there are also some relation with in the northern Sweden. I don't know in detail about Harats yet, but there are some relation with the lichen ecosystem and wildfires, especially. Wait, I was reading this article. Scots pine lichen forest and the wildfires. There's a relation between them. Yeah, this is what I'm getting from my research.
Super exciting.
Yes, definitely. Also, Abi collects so many things as well.
Yeah, what I understood is like the government is trying also to use this power line as a like to convert the place into a biodiversity sanctuary. So like they're applying some mod control like some studies, field studies and analysis, and then they're trying some maintenance plans like enhance the diversity, creating glades or widening patrol paths and removing cut material. And for now they did like 30%, they said, of this power line, and they want to finish the 70% by 2025. And they said through this work a lot of species actually flourished, like Atakan also said, like the butterfly, the marsh fritillary butterfly, and yeah. So I think there is some work is like some kind of work is getting done in this place to revive it again. And we also found something that talks about the vegetations or the plants that is like existing in this place. Yeah.
Very nice. Can we see a little bit of this vegetation? And what do you find about that?
The vegetation? Yeah.
I zoom somewhere.
No, it's at the end. The vegetation. Yeah. So they were saying that this place is consists of gneisses and limestone that is present in the lake of Agnarsjoen. And then they were saying that in Hara they found this kind of species that I highlighted in bold. And yeah, this article, like there is an article that goes a lot more in detail, but I cannot access it. I can only access the abstract, which is this one.
Okay.
Yeah.
Well,
And we
yeah.
sorry, we tried the QGIS, but it's not working.
you
Or I don't know.
You can send out to Hana in an email, and also to Cesar if you want, guys. So just ask straight. I think the emails are in the document, in the main document, right, of the participants. So just please copy us, copy Rebecca and me, but send straight message to Hana to see if she can help you with something specific that you want to find. Okay, so involve her in the research. She's super willing to participate.
Okay. Thank you so
Thank you.
much.
I think there is here this Hara that you find is here. I think that this is actually a different place. I think because they are saying that it's in the Mälar Lake districts, which is more similar to Stockholm. So it says here in Södermanland. And I think Harads, as is the place that you are investigating, is in Lapland, I think, right?
It's in maybe Lapland. You can type it as Harald in Lapland, and maybe the S, because there is one Harald with the L, and with the Harald without S and with S. I haven't.
Which one are you talking about?
It happened to me
That's
also in the beginning that I was naming Harald when the first time that I visited the site. You know?
Okay. Okay.
Yes.
We will make sure.
But nevertheless, I think it's very exciting what you did, guys.
Yeah.
It's super nice point. I really like where you are jumping in. Do you have other images? I see in the right, just to see all the collections that you put.
And I think these are from Drive.
From the
Yeah, this is from
Okay, from the drive. Okay, so yes, okay.
But we will collect for generation as well. So we will add in the Miro.
Okay, very well done. Very well, very nice
Thank
point
you.
of the part too, and very nice the way that you both presented. Okay, so let's say I pick up two things that maybe we can share with Avi and Natakam. One is no, I mean, first formally, I think that it's nice to put these informations in a kind of a vitacora or in a kind of a document that, like a research document, like put it up. It's nice to use as a mood board, as we were saying in Miro, to put it together, but try to assembling exactly what you tell us in a sort of a narrative. Okay, it could be a PDF, step by step, super simple. Don't necessarily to be so graphically sophisticated, just image, paragraph, and as well as was very exciting that you put the links to the article, to the sources, as we were discussing yesterday with one comment of your colleagues. We were talking about the relevance of the sources. And it's nice that you have the links to the article, even if, as Avi was saying, if some of them are still abstracts, so you cannot access to the full article, it's nice to have it in order to connect to the academical community, let's say, or to the more scientific information, and as well as journalists and perspective and government policies. And that, it was very nice from your presentation, that you moved from some journalistic articles to some scientific articles to some more official or institutional articles to talk about policies, perspective of the government, and that give really a hint or a horizon of opinion, which make us be more sharp in our conclusion, or where we situate in the middle of this field of information. I like the idea of the governmental policies, because that give us a territorial or regional plan or national plan, and talking about, and also some measurements, this 70%, 30% reach until now, with a goal of the 70%. That is fascinating, really. Things that could be related, maybe, if you use the drawing that we show you guys of the power line in the north of Sweden, the electricity line grids, Like maybe we can upload it there in the case, no? In a folder, and then you see, okay, this is very much related with what Cesar showed. You remember, guys, all these avenues and we have, and already 30% have been maintained or oriented toward that. So we can, in the rest of the 70%, we can really see this map as a sort of a kind of a national park or a national reservoir, no, that is based on lines, so a linear reservoir. And that's a very beautiful concept, no? The reservoir specific, and as Atakan was mentioned, with some species that are endangered species, that they are thrived in through a policy or legal scaffold that make these linear parks to transform in the reservoir of the future. No? That is beautiful as a point of departure. No? Then, of course, we can question what it will happen with the towers. Are the towers are gonna be using as a scaffold to also other species to grow? What will happen with the line of contact between the crack or the, you know, the scars and when they touch with these lines? What is the correlation between both sides? No? And we can speculate. In your image, you can speculate further. Remember that we can have macroscopic images. We can have territorial images in the AI speculation, but you can also decide, okay, I want to make a section of that. And in the sections, I want to see what is happening, a section of the crack of the failure, which shows both part, the trees in the center with the towers, and also below the underground, no? The information with type of soils and things like this. And that could be one of your final representation, no? Like a section perspective or something like that, okay? Yes, yeah.
I think this is where you start to weave also all these different both this information that you have about these. I mean, to see first of all how does these butterflies look? Maybe we can find an image of them, and then to understand why are these safe zones safe zones? What are the particular components that makes them safe zones, or what are the components that makes the butterfly feel safe or good or thrive? Same, you were also into the wildfires and lichen also there. Why understand a little bit better why those are the conditions, or what are the conditions of them. And then for example, like you said, with the layers of, if you see that it's about soil constitution, or it's about a special kind of you know, and then you can use the material maybe that you find in Hana's layers, or you can find layers in Hana's that she had provided, where that maybe will give you more information. Like you add layers of information on top of each other to also build interesting representation, so to visualize this. And I think already, already thinking about tomorrow, for example, that you can reach really, really interesting future scenarios just with this information that you have here. You can reach very interesting, like speculations about future scenarios. More, yeah.
Yeah. I'm agreed. This toward tomorrow, in the perspective of tomorrow's session, guys, it's very important what Rebecca was mentioned on the specific pictures of this butterfly, right? And then Atakan was also mentioned that they are the idea of what they eat, no? What they eat and who consume them, no? So what is the really, where they are situated in the change of evolution, and then you can establish some sort of a cycle. Maybe a cycle that make you understand that the butterfly coming from the worm, or the worm is coming there, but then they are inserted in the soil. The type of soil is this, the type of butterfly is that, and they're usually these type of birds, the one that consume them, that you eat them, and that you make that could be illustrated in this section perspective in the image AI image generation, so on, no? That we really have not just the stratos, the layers of the information between the soil and the top, but also all the animal life that happen, animal cycle that happen within that. That could be fascinating. No? But the secret is to look into this butterfly and the flora that you mentioned, guys, and as well as this lichen, and have the power line in territorial perspective plus the perspective of Harad that can give you the national this biodiversity sanctuary that Abby was mentioned, but also a more specific approach to Harad. No, I think this AIMA in 3 main images. You will produce a lot of images, of course, in the as you know in AI, but if you oriented the searching into these 3 different perspectives, no, the logic of the sanctuary in Harad, also related with the conditions there, with the type of soil, with the forest fire, and the lichen, and so on, and the specific endangered species, and the scaffolds, the towers as a scaffold for that, but then a vision that show this national reservoir or linear reservoir or biodiversity sanctuary toward the map of grid in Europe, of electricity grid in Europe, that give a planetary perspective, and you go deep into a molecular perspective, cutting that particular section that is the 2 forests and see the soil constitution below and all this change of life cycles. No? All right, so
yeah, because for example, probably you can find in these QGIS maps that what is the top layer of the soil, what is the lower layers of the soil, and that could also be very interesting to then put into your representations as well. So you can really collect information.
This is fundamental, no? Usually we
create map of interrelations.
We always have this discussion with our students about that, what Rebecca is mentioning, and that we usually, as an architect, always draw, or planners or designers or landscape, always draw the line of the soil and the trees growing there, and we don't care about the roots. You know? Something happened below the line. No? But this is the time to really represent all the stratas, all the things that we cannot see, all the layer of that happen below the ground that maybe are connected with all this information that you're collecting. So super nice, guys. Okay, so moving into a PDF as a narrative, have a look of the species in Harad. Okay, this as well as the specific visualization of these specific endangered species, the butterfly and the flora and the lichen. I would say that also you can use the image that we put it there to start to speculate with them. Okay, so and try to make the exercise to put it one to another beside to another, so you have all the scales together, no overlap. Saye and Shuton were mentioned today, no, or as you Atakan mentioned today with your group. All right, very nice start.
Yes,
Thank
guys.
you.
nice.
You.
Please remember send the doubts to Hana. Let us know if you find the email, and please copy us to follow the conversation. Awesome.
Okay, anybody else who wants to get some feedback? Or
Yes. Fatima, Rasha, Nastarang, Itomiko, Sundas, Agil, please feel free to jump in.
Thank you very much. Thank you. It was a good start and impressed me. It is interesting for me to know more about the effects of high voltage electricity distribution on the environment. For example, the effects it has on soil, plants, and water should be interesting. And maybe these effects are different from other examples, like the dam. And it may even affect the presence of birds and something like that. And I think these types of questions are very interesting for me. In the case of the dam, for example, perhaps species of aquatic animals that are food for another groups floats in water levels that endanger the other species that feed on them. And I think these types of debates are very important. So these types of question send our group to, for example, Nasser and Rabab, and I try to check reliable sources regarding the effect of dam construction on the natural environment, especially in the target area, and collected more data. It seems we should spend more time to understand the endangered species and the effect of dam construction. As I remember you mentioned in the first lecture, the height of dam is important, I think, and it caused a lot serious problem. So I think effects of dam construction, this risk may even transfer the effects to area far away from the dam. I don't know, far away from the dam. So unfortunately, I couldn't access to Miro because of my location. But if it is possible for Rabab and Nastran, I'm glad to hear more. Thank you very much.
Thank you so much, Agil. Yes, don't worry. Okay, so just jump to collect your information in a PDF, in a Word document, and as we say, just image, text with the links of your inquiries and your data collections, put it there, and try to make a research book, a research document. No? All right, so it's not necessary to jump into Miro if you don't have it. And I like your point of view in relation with to trying to involve other species. You know, guys, there's something that happened when we start the course, the workshop. It was a dead bird beside of our window here when we are sitting making the here in beside of our desk. And of course, we were sad to see that maybe the bird crashed with the window as it was there. And suddenly we turned in the hours after, and the body was moving, and it was moving by a lot of worms that were consuming the body in a speed that was incredible. Huh? The body was decomposed in less than 1 day. And the day after, once the body was almost just the wings were there, it was completely the skeleton there. Suddenly we see another birds eating the worms that eat the previous bird. No? And it was very exciting to see that circle of life. No, how those fantastic circles of life that nature has. So it would be nice if you can track these issues that you are mentioning, Agil, to see endangered species, what happened, why it became endangered. So what is it that is missing? If it's affected by certain forms of alterations, especially the ones that we are investigating. And like I said, of course, there is a landfill. It was a very aggressive in the moment. Now it looks quite beautiful, as we always say, but it was quite aggressive in the moment that they create these two formation. And I'm very sure that some of them became endangered due human alterations, but then you can track what happened with the species that the predator that was behind the chain, but also the species that these are consumed by these specific endangered species that you are investigating. So you really can have a perspective of what really happened there, and maybe the evidence or the clues are not exactly in this endemic species, but actually in something that happened after or before that species, no? Or Well, you know that sometimes the source of the research coming from going to track back or track forward. All right, so I think that you can go through this. So find articles about Laxede, especially what happened after these strong constructions and what happened with the landscape and certain species, and maybe you can pick up from one of them and track what happened with what is the real conditions today. Also, something that could be nice to investigate there, Agil, is the river bedrock. Some of the samples that we upload, they are living samples. You will see that we found a special microorganism moving in between these algae, a piece of algae that we collect. And that could be very nice starting point, you know, that please feel free to use these images. They are very exciting videos, make stills from that or print screens for the stills. And if you're trying to identify exactly the microorganisms or the bacteria that we find in a microscope, it will be even better, because then you can start to reconstruct this case. No, a small piece of algae that we extract, and then the kind of microorganisms that happen there, and you can see what happened with the oxygen, what happened with the quality of the water. So, you know, as Sevan and her group yesterday were showing us what happened in the river beside in Barcelona, you can also track back the type of bacteria and or type of microorganisms that are present in this place in Laxede. No? Yeah.
No, I think, yeah.
Yeah. Is that clear? So have a look of the information that we upload, Agil, that we found all the videos and very exciting things, and try to see if you can find a way to investigate what really happened there.
Thank you, awesome. Thank you, Maestro. Exactly. You know, this course changed my perspective, and it's interesting that near our house, the birds no longer sing, and I don't know, because it might be because of the installation of the telecommunication tower. I don't know. Maybe I don't know what causing it, and in the local version, I really like to find to research these types of microorganism or even birds, or it is very essential for us today. Thank you for your time. Thank you. And is it possible we as Nastran say, we are organizing the data we collected on board after lunch, if possible?
That's perfect.
That's perfect, guys. Okay, so we're gonna have a very short lunch now. We'll start at 2.
Which is in 35 minutes.
Yeah, exactly, almost 40 minutes. So we run then we have this last presentation, then Tomas initiate the session, and at the end of the day we can come back and you can present your first approaches. All right, so just work on it, and we will have time at the end of the session today to revisit your work. All right, so complete to ensembling in the and as I said, not necessarily need to be a meter. So Nastaran, feel free to put it in a. Oh yes, you are putting in your board. Yes, okay, perfect. We can see it in the board if you have a meter board. Otherwise, just put it in a simple document after that in a PDF. Is it okay? Clear. Sounds clear, Nastaran. Yes. Okay.
Perfect.
All right, guys.
Thank you.
Bon appetit, and see you in 40 minutes. We see each other at 2.
Yes.
Very
Bon
nice.
appetit.
Bon appetit.
All right, please. Well, guys, we want to introduce you. Diego, Aditya, Ashkai, and Ignacio. Well, I think you maybe know Aditya from one of the first sessions. So they were also participants in our previous seminar at the AC in the landscape series, molecular landscape. They brought us, they accept to present today the work that they've developed in the seminar. It's gonna be again a very inspirational lecture, and thank you so much, guys, to jumping and taking your time to join us. So the stage is yours, please.
Thanks for the invitation, Alejandro and Rebecca. So I will share the screen. It's a short presentation. It's like a resume of the last presentation. So, and please let me know if it's super lag because it's a video. So
okay, I don't remember what the video has audio, Ignacio.
Yeah, I'm going to share the audio also.
Exactly. When you share the screen, share the audio. Just remember to share the audio first. Okay.
So Aditya, actually, are you there?
Yeah.
Cool.
Thank you everyone for having us here. It's a great honor to be presenting before you all. Hope you like this. Okay, we are joined by Ignacio, Diego, and Akshay. We are going to present to you. Our project was for the molecular landscape seminar, the Bessos River, our main concentration of interest. The Bessos River is formed in the Catalonian mountains, and it flows in a northern and the southeastern direction, and it finally drains in the northern part of Barcelona into the Mediterranean Sea. Now, amongst all the parts of the river, the mouth where the river meets the sea was perhaps of the greatest interest to us. As you can see here, this is the time lapse of the entire space. So like this part has been, subjected to a lot of ecological destruction, and like there were thermal power stations which were coming up, there were manufacturing stations and all those things. But the mouth was of primary interest to us because of the fact like this was the area where we could see the affected ecology which was merging with the pristine nature. And for us, like this play between the elements was of main interest and the topic of our investigation. So we have the power plants, we see the outflow of the waste materials from the power plants, and on the right we have the sea. So this was the part where we collected the samples in order to get an interpretation out of it. This is the water runoff areas that we have, and this is a video showing the part where the industrial waste is coming out of the thermal power plants.
So we started searching which type of materials is inside the water. So in these parts of the river, we have lead, phosphorus, and mercury. And with this information, we started looking not also the earth materials, let's say, also the biotic materials. So this is one of the samples in the water near this kind of factory. So, and with this information, we started creating prompts to put in Midjourney to create merging prototypes, let's say, to combine the microscopic world with the macro world, trying to have all of this information of the materials and the samples inside the image. So this is the first one. And we tried to catch different type of samples. One in the water near the plant, another one in the in the earth and the dry part, and another one in the middle point to compare which type of materials and if it's going in these samples, it's something alive. So here we can explain a little bit like the prompts later, but it's trying to merge this type of bio more natural things with the artificial parts. All of these samples, we collect them, and we scan these samples, and we scan with Polycam to have a 3D scan, and that information we put in the Midjourney. So let's go. This is another sample, and after this we Aditya, if you
Yeah,
want to
and
explain
after all this, the moment when we collected all these samples, we studied them, we realized like, so as Ignacio very rightly told, we collected these samples from very specific parts. One was right next to the industrial area, one was where the sea made the, where the river made the sea, and one was right next to the sea. So we had those liminalities captured in the microscopic world, and like we understood, like when we saw the when we saw through the electron microscope, we saw certain properties. The properties being like when we were collecting from very near the industries, they had certain elements which were not there when we were collecting from near the sea. So we could see those things, we interpreted it geometrically, we could see the growth patterns as you can see here. And after that, when we got these findings, we tried to impose them on the macro world. Like we took the photos and we tried to impose our findings through Midjourney prompts, and we tried to see how the macro world would look like if we gave in the prompts which somehow corresponded to the microscopic world. And these are the results as you can see. And after that, as I said, we got to know about the certain geometrical properties, like we knew about reaction, diffusion, we knew about growth. So we went again into the algorithmic modeling part. We tried to encode those things algorithmically so that we could make our own interpretation of how the space would look like. So yeah, that's it. Thank you. Any questions? We would be happy to answer.
Thank you, guys. Fantastic. So nice to see the work again. And your maturity explaining this in a very fast way, in a very solid way, just with a little bit of reflection after this, a couple of months. Very nice work. Please, some questions for the group, guys. Any doubt, any comment? Mic is open.
Can I ask something?
Yes, please, Nathan.
I just wanted to know that what was the aim of you with this project? Because in the last thing that you just showed, it was the microscopic world in the cities scale, and I just wanted to know that what was your idea about when you start?
Okay, so I think for us, it was mostly about how we can reinterpret or re-speculate the macro world through the eyes of the micro world. So as I said, like we had this growth patterns, and we also had this turbulent forms in the sea. Like we saw this turbulence going on, and so we wanted to think like what if we could somehow encapsulate this turbulence and show it in the urban space. And that's why like we had the factories which were right beside the river, and we tried to encapsulate those areas with this turbulent vector fields to just have an artistic speculative interpretation. Yeah.
And also it's how we can visualize these kind of things.
Yep.
It's not only about how to reduce something, it's something to visualize the things we can see.
Thank you, that was great.
Thanks for the question.
Anybody else?
Hey, hello, Walter. Nice to see you.
Sorry. Good to be here. Amazing presentation. Sorry, I only caught the end of it.
Yes, catch up with the video, okay? We will upload it again.
All right. Thank you so much.
Don't worry for this, yes.
Yeah, we can like send the video. We have the video in YouTube if you want to see it again.
It would be
Perfect.
great, Ignacio. Place there in the
Send us the link.
chat.
That
Yeah.
would be amazing. Thank you.
Rebe, you have
Yeah,
some
I know.
comments from the group. Yes.
Yes, I think
nice to
it's
see you.
yes, really nice to see it again. I think it's the way you are visualizing also in the beginning of the presentation, which is across the groups actually. I think you are very clear with like you're localizing exactly where you collect the different samples to really understand also that it becomes really a comparative study. And also through this the scales, how you are moving in between the scales makes us also understand how they are that they are interrelational. And also this, like what you were saying, how you're merging the natural and the artificial is very, very it's interesting to as a way to explore, of course. And you are really exploring the interscalars through different technologies also. You are also making these algorithms, which is and augmenting or exaggerating and just allowing yourself to be free also to explore with the help of those tools. As a way to create scenarios for the future. So yeah.
Very nice.
Yeah.
I'm agree that there is seeing this. Well, first, of course, thank you for accepting this, and became quite inspirational lecture for the other students. And I can see again several nuances and several details that this piece of research have that is quite exciting. And I'm agree with both of you, with Ignacio and Aditya. There is about the translation, the scalar translation, what Rebe mentioned as interscalar mediations, we can say that, and the experience and the visualization. There's two moments that are quite strong in the material that you produce. The visualization, especially because you use these tools that Rebecca mentioned, the way to, I think there is a very nice moment when in general, the way that the rigor in the research steps are quite nice. So the way that the samples are collected, the historical pictures of the river, and then some of you also extracting or getting samples from that, the identifications of where you are positioned, plus then immediately a scalar of the sample, and then immediately a scalar of the microscope. That is in the interscalar visualization that Rebecca was mentioned. And then there is a process of mediation that is quite nice with the tools. I think it was with CREA, I guess, the one that you have a comparison between the affected ecosystem and the new one, and the prompting, and how you can see how the hypotheses are simultaneously active, and you can see what, based on these microorganisms that you that detected, how through CREA you was able to visualize instantaneously what really could happen in the future if these issues take another direction, and especially give it's a kind of optimistic view, because it's the same land, but enhancing let's say the behavioral patterns that you found there, and amplify, as Rebecca was mentioned, through the tools to visualize. Yes, it's possible. It's already happening in a microscopic scale. Could happen in another scale. That are connected with also what Aditya was mentioned. It's about bring behavior of patterns of behavioral conditions in a scale that are invisible, and try to see what happened in another scales. And I remember, yes, some of you, Ashka and Diego, manipulating the coding, the codes, and trying to find what are really the codes behind embedded in nature that you can reproduce and amplify to a macro scale. We will have today, after you guys in the afternoon, we will have a session with Tomas Mena, who was one of your jury in your presentation. He will be deliver some growing algorithms, growing systems, and he having downloaded some algorithms that you can manipulate and slide it and see really try to understand what is the logic of growing and behind those systems, and to see what kind of a speculation you can do with that. No? And I really like that there are another level of speculations that are going beyond the CREA is when you present this kind of a visual scenarios, urban scenarios, where these meta structures or parastructures became the scaffold of future evolution. No? And that is quite very speculative and very envision a subjectivity or subjectivize the reality in a very beautiful and positive way. So thank you so much for this. I appreciate to see you all again.
Thank you so much.
Thank you so much for your
Are
opportunity.
there any more questions?
Thank you.
Sorry.
Yes, Diego. Yes, we hear you.
No. I was just going to say, there is like this focus we did in this project about behaviors, but the thing is, we also focused on how this would be able to be like experienced with a VR headset, which also we had at the moment. So we had like these 360 renderings that we wanted to push the geometry as exaggerated as possible, so the viewer could like be immersed in this like dialogue between different behaviors. And that.
Yeah, that part was very nice. No, after the CREA, then your 3D models, your parametric models in Grasshopper, and then you put it the panoramic. No, can you explain a little bit the workflow of that?
Yeah, it was a little like we had to improvise among because the tools weren't that. I mean, because Photoshop used to help us, but the 360 features have been removed recently, so we had to have the help of other software. But in essence, like at the end, the result, the output we got in the 360 renderings and how the Midjourney generated images merge with this VR renderings, it was like very satisfactory. Like it was really, I mean, as a team, we were very satisfied with the pictures. We can also maybe send later the links to that to those images.
Oh, please, if you can share the panoramic render, it would be very amazing with them. They would be nice, Diego. And yes, I'm definitely agree with you that was a very experiential way to see a render, no framing with a format, but instead immersive, and that was very good point to enter in your research. So thank you for sharing that. Yes, and so nice to see you, Osman. Thank you for visiting us.
Hello, Ale. Hello, Rebecca.
Hey.
Yes.
Congrats on the workshop.
Thank you so much. Oh, awesome. All right, guys, and welcome, Tomas. We have Tomas here now in the room, in the house. Thank you. Well, I can suggest maybe to make a very short break. Are you okay? Meanwhile, Tomas setting up everything. Guys, thank you so much for jumping, and please join us anytime that you want. We will be here also tomorrow and on Sunday. If you have a chance, jump in to hear your comments and participate in the discussion. Right.
And stay for Tomas' lecture or for Tomas' session here if you can.
Yes.
It will be nice.
Yes. All right.
Okay.
I need to go, so thanks.
All right. Thank you.
Thank you.
Thank you, Alejandro.
Ciao, abrazo.
See you guys.
Ciao, ciao.
Gracias.
Well, or maybe we can, yes, if you feel that we can start over, are you ready for this, Tomas? Maybe you can explain a little bit I know that you have been uploading information in the drive. I don't know if we say 2:30, but if all of you are agree, we can just start right over. Are you agree with that, guys? Now that Tomas is already here. Is it okay? All right, go for it. Mena, stage is yours.
Okay, hi everyone. I'm really glad to be here. Really proud of Alejandro, Rebecca, and all the team participating here in Dita's workshop platform with this nice workshop. And
I can say maybe before, yes, sorry to interrupt you, Thomas. I introduced you the first day, but maybe some other students have been joining us the rest of the day. I just want to explain a little bit the context of this for the ones that were not in the first session. Not with Tomas, we have been working for a while together, researching and practicing. He's also part of the Laboratory of Planetary Diplomacy and also one tutor in the Studio 12, as well as in mapping changing ecosystems. So he has been sharing the academical environment with us for a while. And also he was jury on the previous seminar at the IAC. And Tomas is having a specialized in computational design. He's despite the fact that he moved across different fields, is very much his favorite, or he feels comfortable in this space. It's a space that he have been pushing more research steps. He holds a master in computation design from THO University of Applied Science of Art in Delmont in Germany. And the projects that he's developing are oriented toward computations and parametric research tools, especially, not just using the tools, but also creating tools for research and for developing, which is particularly what if I can say, one of the parts that I'm most exciting about the research that we have been carrying on is that we have been exploring different tools that are available today. But we try always to push forward, and it's something that Tomas is always pending, to have a second lecture or a second alternative view to use the tools. So despite the fact that he's quite expert in this ones, he always trying to find the way to make it the correct use of them, or an alternative use of them, and move forefront, but also in a more speculative in relation with digital tools today. And as I say, he's a guest teacher in MA Studio 12, master students in Mumbai University, the same as in the freestanding course mapping changing ecosystem. Very much the research field of Tomas is algorithm workflow for automation and interoperability. So welcome, Tomas. Stage is yours now. Yes, please.
Yeah. Okay. Thank you, Alejandro, for that introduction. Yes. I hope everyone is well. And first of all, I know from Alejandro that some of you are Grasshopper users. I don't know what's kind of the level across the whole group, but what we're gonna do, we're gonna set some. I have prepared some examples for tools that we can use to support, let's say, the image creation for the research. Something that can be like a point of departure, then can be extended with all the other workflows that maybe Alejandro has shown, and also it's important to stay in the context of this subject. So first of all, I would like you guys to go to the folder that Alejandro shared. Let me just start sharing screen right now, and let's just share this screen. And so in the folder that we have as a common source, I created in the provided material. I created a folder that is called Grasshopper, and there we will have plugins. So I uploaded a set of plugins that we are gonna be using today, and as well some examples, so we can maybe you can follow along the session, and then we're gonna trying to start from more simple to more complex examples. So I am gonna keep this thing as practical as possible. Sometimes I give lectures about this, but it could be much theoretical, but here we want to just go ahead straightforward to the tools. But nevertheless, it's important that let me just bring this thing here. Sorry. And just gonna prepare here the screen for you guys. Great. So important here for just as a preliminary explanation here, I'm just gonna bring a little bit the whole cameras here so I can see your faces. It's important that we understand these tools. They're used for several different type of purposes, and I like to combine these tools so we can start like reimagining in a creative way some imagery that will support different type of topics. In this particular case, we are talking about these environmental protocols that maybe all of these microscopic species have into regenerating terrains or landscapes or ecosystems, and they have their own protocols of working. And ideally is that we, instead of replicating this type of organisms in an accurate way or try to model them as they are, we just kind of assume some behaviors. And this behavioral approach, the idea is to reproduce the logic of maybe behavioral logic of these agents. And ideally, this is more a creative process than a replication process. So the tools that we're gonna use here, I just set these tools in a way so we can have some sort of first image or first approach of how this can look, can be developed and let's say leverage. But this can be combined in any type of ways. So this is really open and just proposing some workflows that they work nicely, but this can totally be subverted and tested across many other type of context or with many other type of inputs or data. So that said, let's start with some let me just take this thing out of here. Let's start just with some examples. So we're gonna start with with organic patterns. So we're gonna start with like a series of of steps here that I've been developing. Kind of again, this is based in a shortest walk algorithm, and maybe some of you already know what the shortest walk is. It's an algorithm that serve or aims to find the closest path in a series of paths inside of a network. And this algorithm can work inside of. I think there's some delay. Okay. This algorithm can be applied to generate several patterns. And then after that, we can produce a shape that's gonna somehow resemble an organic, let's say, agent or species that is growing across a certain surface. Normally, let's just start here with what are the inputs. So here we first create like a network of stuff of lines, and the way that we do it, I normally, and this is an example that we used to work in the laboratory. We mapped a lot of data on topographies. So I use one of these topographies to do these examples. And this is a topography that is being converted into rationalized into a untrained surface. And this is important because what we want to do is just to have the ability to act or parameterize geometry or values on top of this surface in a really controlled way. The only way to do that is to have an actual surface. This surface is coming out of a mesh that was digitalized and processed by me, and then I turned it into a surface. And you can see here that this is a surface resembling a terrain. If we actually bake it, we will see the UV you will see the UV distribution is quite homogenic, and this is what we want. We want to have such a nice mapped and regularized surface, so we can start to act on it, for example, with parameters. And these parameters, we can then control them in a discrete way. For example, if we map a certain point on this surface, we can actually control that. We want to know and have discrete control on this or more points. And then I'm gonna show you why this is important. So the way that the network is created is first we have our rationalized surface, and that surface we just populate it with a certain number of random points that are gonna be appearing on top of that surface. These points are gonna be the input for a network that is gonna cross-reference all of these points in all, let's say, combinations of indexes possible. So they're gonna connect with all of the inputs or all of the points in the possible way. And we achieve this. I'm gonna just start showing really slowly what components that I'm using. So first I have my input, and you will find in the example, if you download it, you'll find the input there as an internalized data. So this is a surface here. You will see it here as an input surface. And then we're gonna use the populate geometry component that you can find it on the vector tab under the grid menu. You'll find this component. And this component, what it does is just populates any surface that you give it with a random distribution of points. Here you can change the amount of points. Here we have now 100, but we can increase or decrease. Here we have the seed. This seed can change, and we will change the way that the points are distributed. Like the random engine is going to change because of the seed. And these are pre-existing points, maybe points that you want to approximate in use as a basis of distribution for this component. Right now, we're not using any base or point reference. We're just gonna let the component create these points randomly. And after we create these points, we're gonna use this component that is called proximity 3D. You'll find that under the mesh menu or tab. Under the triangulation submenu, you'll find there the proximity 3D. And what proximity 3D does is just combines all of these points in a meshing algorithm, cross-referencing all of them. And what we get is this type of mesh. This mesh is going to be interconnected with all the points to each other in all possibilities. So we will have a pretty dense mesh. For example, let me just try to change this so you can see the difference. If we change the values on the point generation, you will see how the mesh is going to increase its density. So that means that here you have all of these possibilities of connections. And this is going to serve as the basis for the shortest walk algorithm to find a specific path that we're gonna feed them as like the input or the let's say what we want the algorithm to find. So after we have our mesh, we are generating our mesh. Here we have certain values. These values can change. I just leave it as they are to just provide an example, but you can test with these values. Also here you have the topology of each node, let's say, and how they are connected. So here you see that for each point, you have a number of indexes of what are the lines that are connected to them. So we can increase this or decrease. So we can, for example, here at 15, here we can increase the value and we can actually generate more connections. And you increase the density of the mesh, so that will allow the algorithm to choose from many other connections. So, and here you have all of these topology numbers here that we find in this topology output. They are referencing the index of each line that are connected to each point. So in this sense, if you want to control more discrete this algorithm or leverage this information, is totally possible with each index of the lines. So this is pretty useful. So after we have that, we have I never normally I do it with less dense mesh, but we can keep this density. We can try it. Maybe I hope it doesn't melt my computer. But here then we're gonna work in the other inputs for the shortest walk algorithm. So as I was telling you, the advantage to having a parameterized surface is that we can actually control and map really specific things on top of that mesh in a really discrete way. So using the evaluate surface component that you find in the surface tab under the analysis submenu, we can actually parse this surface with this other component that is the MD slider that you'll find on the parameters tab under the input submenu. And with this parameter, what it will do is you can set a series of parameters in 2 dimensions. Let's Let's see U and V, and this is how actually a mesh is created in a U and V direction. And with this slider, you can just provide a series of values that would tell the component, the evaluate mesh component, where to evaluate that mesh. But it's important, and bear with me if you already know this, but for the people who doesn't know this type of methods, it's important that I explain that. It's important that to understand what are the regions and the domains that we are working with. A mesh is just a parameterized domain that could have any dimension. You can have a X type of dimension in U and X type of dimension in V. That means that can be any size. But to actually have a control over that and somehow do an abstraction on those quantities, what we do is we reparameterize these parameters and we turn this mesh into a unit mesh, a mesh that has from 0 to 1 in one direction and from 0 to 1 in the other direction. That's important because we don't know like how big is this mesh or any mesh that or any surface that we're going to have as an input. But if we are able to reparameterize them, that means that we can control them with a set of values from 0 to 1. No, doesn't matter the size. So and using the MD slider, this is what we will get. We will get a double here. There is a coordinate, let's say as a coordinate, like a point with X, Y, and Z. But you notice here that it's going from 0 0.2, 0 0.3, and 0 because in Z we don't have any elevation. We're only parsing in 2 dimensions. But here the values go from 0 all the way to 1. And this is covering the whole span of the surface in both directions. And that's why it's important that we do the reparameterization here in the input of the mesh. That's what allows us then to reparameterize everything. If we don't reparameterize here, you'll see that the mesh is not gonna move that much away from like the center or the origin point of the mesh, because now it's just understanding that we are only acting here in the 0 to 1 value, and while the mesh is way bigger, so it's gonna be there. It's not gonna move. So if we reparameterize here, then we assume the whole surface as a unit surface that we can actually reparameterize. So with that, we're gonna create one point, and that is gonna allow us to connect to all of these generated points in this way. Let's instead of doing this, let's gonna do this. So here you see, from that point we can connect to all of the points that are being generated. So, and all of these lines are gonna serve as an input path for the shortest walk algorithm to find the shortest walk using this path. So if we, for example, we open this path, you'll find that the shortest walk algorithm then starts to find all of these shortest path here. We can actually change some parameters here. If we start changing also the generation of points, if we change what I changed before, you'll see how let's just hide this a bit so you can actually see the pattern here. So you see how this pattern, this algorithm is generating all of these kind of branches, kind of as a branch, like it looks like a neuronal path. If we start changing the position of the point, you'll see how all of this is going to change automatically, which is pretty cool. Let's just erase this. So this is a way of creating like a first version of this, which I find pretty cool. And I'm just gonna, here it gives kind of a small error that it doesn't affect the result that we're seeking. Then we're gonna change the inputs and it's gonna correct that. But we're gonna keep going forward so you can see what is the result of all of this. So if we let's just settle here with and just put it in 2D. So we see more kind of the pattern view here. So using this input, we can go forward. What it's gonna give us is gonna give us a series of polylines, curves or polylines. And these polylines are actually all like starting in this point that I gave, and it's just kind of looking through the whole network. So each of these branches are all of these polylines are being repeated for this kind of branching. And if we want to keep using this for what we're gonna use further, it's gonna be too much information. There are too many duplicate lines. So that's why what we do is we just explode all of these lines, and the lines that are gonna be on top of each other, we're just gonna get rid of them. We're gonna get only a set of unique lines. And so here with this is explode component. With the explode component, you can find in the curve submenu and the menu or tab in the submenu of utilities. We're gonna get all the unique lines. So you see here that we have 412, and this is a component that is coming with Rhino 7. This is a plugin called Kangaroo that is one of the most used plugins in that's what like comes already installed in Grasshopper. And it has this component that is called Remove Duplicate Lines. You will find it in the Kangaroo tab under the utilities. And what it does is just take all of these lines and it just removes everything that is duplicated. So from 412, we reach 149. So this is kind of the clean set of lines that we're gonna use. After that, we just join the ones that are able to be joined, and then here we have our set of curves. Now we're gonna use another plugin that is used for creating volumes along lines, and is another plugin that is called Cocoon, and this plugin uses an algorithm that is called the marching cubes algorithm. Somehow it kind of sets a lot of cubes along a set of lines and starts to create kind of a volume across all of these lines. And then we can refine that, and then we can have like a really nice mesh out of that. But also, before that, we're gonna have a small slider here that's gonna help us to recreate these lines. So here we're gonna have, these are the last polylines that we have. And then here we're gonna kind of re-rationalize these lines so we can have the ability to animate this, the creation of this image. So for that, after I join all of my lines, I have something that is called the discontinuity points. In these points, this component, it takes each line that is being joined, and it's gonna find the discontinuity point of each line, and it's gonna give that to me in a separate branch. So this is pretty cool because we have, as a branch, we have a series of points that we can then create as a polyline. Now with this polyline, that is this is a step that I do kind of to be really clean. Maybe this could be somehow skipped, but I like to keep the control of what I'm doing. So I really want to know that I'm acting on each polyline and I have a separate polyline. So here we have a separate polyline in each branch. You can see them. We can list them if you want to see what are the order. If we list them, we will find that. Sorry, I just grabbed it. We'll find that this is the first polyline, for example, and if we have, if we want to list them and a bit to see what is the order here of all the polylines, you can see all here, all separate polylines. Maybe if we can join them here, we can have the same result. So that means that maybe it was not necessary to do this, but I try to be sure that what I'm doing. So here I have the set of my polylines, and I'm gonna just divide them again to have like a certain point of a certain quantity of points per each line. And this certain quantity of points is gonna allow me to recreate these lines from 0 to the last point. And this is how we do it. So then after we have these points for each line, we can list them. And because they are all separated, we can each list of points, and we can recreate this like this. So we can recreate the growth of this pattern from each set of points. And this is gonna be interesting because then after we create our shape, we can then animate this and to give the illusion that this thing is growing. So after this set of points, I feed that into this is called interpolate curve. This is a component that's gonna interpolate all of these points. It's gonna create more as a curvy line, and you can find that under the curve menu in the speed line sub tab there, and it's gonna give us a bit more of a curvy here polyline. So, and now it starts kind of the fun stuff. So let's start. I'm just gonna skip this a bit and this funky esoteric set of components. I'm just gonna go forward a little bit to understand what is the process to create our actual final volume. So I'm just gonna activate this. Maybe it's gonna take a bit because this it needs a bit of computational power. And the idea of these components now, these are now the Martian cubes algorithms, and this is, you can find them with the Cocoon plugin. And this is just preparing how all of these curves are gonna be changing. And so you feed all of these curves. Here you give the radius, a main radius that's gonna like have all of these lines, and they're gonna grow and be kind of a volumetric mesh. And this is the radius that we want to have. And then here is this input allows us to change a bit this radius along these curves. Maybe the radius can change several times and give more kind of the illusion of something that is more organic, or is not so homogeneous. And because we're working with some kind of organic shapes, we want to have this. So the result of this is going to be this type of shapes. And this is now is a mesh that is being generated out of this algorithm. This mesh is, here you have target ISO value, like the ISO value that we want for the mesh, and this can change, and this is gonna alter a lot of the results. The cell size, and then we're gonna have to execute it. So we can, if we say false, maybe if we change this a bit, you will see how all of this is gonna change. It's gonna take a bit, couple of seconds, because this is a heavy computational method, and you see that it changes a bit. So even if you move the sliders a bit more or less, it's gonna change. So after that, we are then we're given a set of meshes, but these meshes, what's cool is that because we used as a basis this surface, and this surface changes in three dimensions. This mesh is also following this surface, so it's adapting to the surface. So this is pretty cool because we can input any surface, and then it's gonna change and adapt itself to any surface. And then after that, there's a smoothing algorithm. So it takes this mesh, it converts it into a more smooth mesh. So it changes a bit its width and its values, and what we're left with is even with something that's more organic. Here you have other type of parameters. Maybe you want to test them. I won't go over each one of them because it's going to take so much time. And the result here is going to be a mesh that we can then even make it smooth with a Catmull-Clark algorithm that you can find also in one of the plugins that I uploaded. It's called Wavebird. And this Catmull-Clark algorithm is going to smooth even more the mesh. It's going to make a really smooth mesh so we can use either for 3D printing or for have a nice renderings or whatever. So, and what we're left with is this type of mesh. So this is pretty cool already. Let me just put top. And we have, actually, we can bake this. If we bake it, we will see like how this mesh is actually, it can be used. Let's see. You'll find that the mesh can be actually, it's a 3D mesh, it's a closed mesh, it's a valid mesh, and we can actually use it for whatever we want. And this mesh is being generated and is resembling one of the stages of lichens. And lichens have like several layers, and this is just resembling one of the layers of the lichens. And then we can just create any type of the logic of how the lichens work. We're not just reproducing a lichens, let's say exactly how it is. We're just reproducing the logic a bit, finding the logic behind, and then creating an image that somehow resembles that. And maybe we can fit this further into an AI engine or whatever to create a more images. And that's why it's important that we have a nice surface that we can use and leverage for that. And we can use this as a landscape. So this is pretty cool. I can go back here and just explain let's just hide this a bit and just change here the visualization method, and it's gonna be full screen here. So here we're left with this type of mesh, right? So let's go back here and just explain this a bit. And this is really a grasshopper thing where we use certain functions to create or generate certain values that we want these values to affect certain stuff in a way that we want. And we can control them in a more like dynamic way, more intuitive way with these type of functions and with the function curves. So ideally, what we want to change or modify is how these previous the radiuses of all of these branches, they change if we disconnect them, for example. We're gonna see that, and actually what we want to is to lower a bit the computational load here. It's just to turn this up, and it's gonna be easier. Yeah, so you see that here all the radiuses they're a bit continuous. They don't change that much. They just kind of merge to each other, and when they are closer together, they just kind of connect to each other. But if then we feed these values here, what allows us to these values is that to change all of these radiuses across the whole curve. So you'll see that, for example, here things starts to be more not regular. You see here it changes. Here it changes a bit also, and this is controlled by this component, and this component is or this set of components is what is creating a range of 10 values and remapping them, kind of changing its values. Here you will see here from 0 to all the way to 5. This is from 0.5 to 1. So this is kind of the main domain or range, and it's subdividing this into 10 parts, and we're just feeding them through this function. And what this function does is just changes a bit all of these values, and then we remap them into the actual values that we want. So these values can change as well. Here we were from 0.5 all the way to 1, and here we're going from 0.5 all the way to 2. So we're trying to duplicate a bit to change a bit the differences of radiuses or the scales, and using different functions, so we can change this function. And this is just optional. You can skip it because this takes a lot of computational power. And because of this is already taking a lot of computational power, this type of generation, what we're gonna do is just to show how we can use this to create an image. I'm just gonna simplify this a bit. And we're gonna, instead of creating all of these nodes, we're gonna kind of simplify this a bit. So this is another way of creating these things. Instead of creating, connecting all of these points to one single point, I'm just gonna use this line. We're gonna project all of these points in this line, and this line is gonna work as a path to create more connections. But these connections are a bit smaller, so it's gonna be easier for the algorithm to find the ways. So if we fit that here, you'll see that. Sorry, here. You'll see how how this mesh is creating all of these connections. But actually, what I'm gonna do is instead of connecting to all of the generated points, I'm just gonna connect it to the point that I control. So it's a bit easier. And this is gonna be a bit less heavy to just show the way that we want to generate this. Then you can do it with your full net. So now we're gonna create just one series of branches, or let's say less branches. And here you can see how these branches are being modified. And then we go through the algorithm, we do the whole thing again. And what we're left with is with this set of branches. Maybe here we can lower this a bit so it's less heavy, because I think this increases too much the resolution. So and here the cell size maybe we put it to 1 and makes it a bit good. 0.8. Or we increase this, maybe it's better to increase it. So yeah, I think if we increase it, it goes a bit faster, so it doesn't have that much resolution. So we're left with this, and we put here less ISO. Yeah, so it's a bit more rough, and then we can play with this. So here you can see here how this modifies the whole radius of these cells. Right now I'm using a specific function, but if you change, this is a sync, you can change that, like a sign function is gonna change it in a different way as well. Or you can change other type of like there's a purling noise also, which is it gives something more like random changes to this. And so we can actually increase the disturbance of this or less. And this type of modifications are just fun. But what is cool is that because we have this series of points, we can just recreate how this is growing with the slider, which makes it pretty cool. And then if we then smooth that surface and we go to the surface smooth, we can actually recreate this, and it looks even more organical or more like alive. And we can keep going to the cut mode Clark, and then we'll have this really smooth shape. So, which is really cool that after we have our own, or the final shape that we want to keep, we just can come here to the slider and we can animate this. It's gonna animate like step by step into different, for example, into different images for the selected viewport. And you see here, it's gonna give you a bitmap, and depending of the amount of frames that you want, you're gonna have the amount of bitmaps that you can then animate as a movie or a small animation. You can just kind of, if we, for example, let's create a new folder here. No, let's DigitalFUTURES, create animation 3. So we put this in the, I don't know why I didn't. Well, let's choose this new folder here, and let's lower a bit. Let's just put 20 just to make it fast. You can change the viewport if you want. You can change We can keep it on top. You can change the amount, you can change the resolution. Here is more resolution, so we do it faster. But after you set 23, then you create the animation. And this animation, the whole set of the whole of images, you'll find them here in your folder, and you can create a movie. Of course, you can like place this better, but you can create a movie out of it. So this is pretty cool. You can put more images, so you can create like a more like smooth movie. You can change the viewport, you can put it in perspective, you can actually apply a material if you want. So this is pretty cool. So this is, let's say, this is the first thing that I wanted to show you guys with the shortest walk algorithm. And this series of other tools to create a nice organic pattern that's gonna replicate the logic of some layers of lichens or other type of like fungi or other type of organic formation. Maybe corals also can be replicated like this. So, and this can be then integrated into topography and terrains. And you can see here terrain, and it's just adapting to the terrain. Maybe it's not a terrain, maybe it's something way smaller that has more volumetric quality to it, or smooth quality, and then you can from this point of departure, then you can let your creativity just kind of run and do whatever you want. Any questions?
I have a question.
Yes.
How did you import the topography, the
Well,
image, the surface that you have?
This
Yes,
one.
here.
If you
Yes.
go to the example folders, this example already has that topography included.
There. Thank you.
So it's as an internalized data set there. So you can use that. If you have another topography, if you have another mesh, you just put it there and yeah, work with it if you want. Any other questions?
Tomas, beautiful, fantastic. I think that maybe we can make a break for this model.
Sure.
I was thinking in the options that you made toward the deliverables that we set up in our document and in the brief, especially the last part with the stop motion of the growing patterns.
Yeah.
So they can have an output of the frames, and also they can screen. Let's say they record the screen and just make the slide. No, do you find difference between these two in qualities, or both of them could be an alternative? No?
No, depending, because if you have a set of frames, you have the control of resolution and amount of frames. So if you want to have a really smooth animation, you just get more frames and more and higher resolution. But if you sorry, if you want to have it really quickly display, we just maybe we can just get rid of the thing that give away that we're working Grasshopper here or in Rhino and just animate this like that. Maybe we put it here because now unlike in the middle of the, and with this we can say, okay, let's you can already do this and maybe have a quick a capture there of that generation, and maybe that you can have that as a GIF or whatever. So there are plenty of options here to work with, and maybe you can get this mesh. If you are like a well advanced, you will have options to connect this to Blender and maybe create this same animation way, this kind of transition with Python interoperability tools to Blender and all of that. That could be like, this opens a lot of possibilities. But this way is really fast, it's really simple, and you have already set the whole setup there to work with this. Okay.
Super. I think that is very straightforward to play with this algorithm, as Tomas was suggesting, guys, and slide it and try to get some kind of nice view of that complement your narrative. And the ones of you that want to try even to inhabit them, so put in a perspective that you are part, like in the scale of a microorganism or pollinator or so on, even better, because then we can really set up the scale of the microscopic landscape.
Yeah.
As well as the last example that Tomas showed, that if you place it in a topography, put a camera that could be also inhabiting the surface of the ground and be able to attach this growing pattern to a territory or to a landscape, no? And that will combine
exactly.
the two scopes, and very nice.
It's cool because it just adapts to any surface that you give it. So it would just, if you change the surface, if you change the surface, it's gonna just change also its way. So it's pretty cool.
Fantastic.
Great.
Super nice, Tomas. Okay, so let's start again. It's 15:20. We can give 15 minutes. Let's say 15:35. We come back at 15:35, guys.
Okay, great.
See you very soon. Very nice.
Sure.
Great. Okay. Welcome back. If there is any doubt, guys, please drop your questions or just open your mic if you want to ask some questions. Now that I know that you have been trying and testing some of the tools that Tomas have been introducing.
Thomas, in the last example,
Yes.
if you wanted to have more height variation, so right now the output's kind of flat.
Here in the surface, you mean?
No, the output, like the after you're done with the shortest walk, it's still kind of flat.
Yeah.
You know, so two questions. If you wanted to have more Z variation, and if you wanted to have more thickness variation from cocoon, like the cocoon's fairly uniform too. Imagining that this was like a pile of sticks that washed up on the shore so that they'd have different sizes rather than this be kind of an algae growth.
Okay. Well, for height, it could be right now it's adapting to the surface. Surface can be, for example, since we are ready, let's just hide this thing.
So the height of the surface makes the difference with the height?
Yeah, that of the set variation. So if, for example, if we instead of using that surface that is internalized, we just let's put this one, right? And we set this surface, the one that I baked. And the surface, because it's baked, you can basically scale it into the set, right? We have more like dramatic changes there. This is one fast solution. This could be done in different ways. So instead of having this surface, we just apply these other ones. Then we will have certainly yes. You will have more set variation here. For example, you will see that is more pronounced, the set variation. And then here we have to, okay, here's not working right now because, okay, and then we will have more of a yeah, it changes.
Z height.
Yeah, Z height, exactly. And of course you other type of response here. I mean, this can be changed in this case because it's just attached to the surface. If you modify the surface, it's gonna modify the output, of course. And the more you modify the surface, the more height it's gonna change.
So you just need some topography for it to have to get over, right?
Yeah, in this case, you can do it. You could also, if for example, this is a bit more intensive, you could change the points of the polylines here. So you could have a random a random set of series, sorry, lengths. We can generate random values for I don't know what's, let me see the point here. What's gonna be I don't know what's the elevation, but for example, if we can generate 0 to 1, maybe we can put 10 here, or let's put 15. What I'm doing is just creating a range to have a series of random points from 0 to 15, and then we're gonna create the amount of values for each point that define each polyline, and then we can move that into set. For example, this is just quick. Yeah, here you see all the points coming from this. Maybe here, it's just changing random in the random way. We can just go back to the flat surface so we can see how this is changing a bit more. We can increase this to, let's say, 50. So we can see here how the things are changing. And then we feed this into the polyline, and then it should create also more set variation.
Right. Okay. Gotcha. Wow. That's,
And this is just
that's
kind
a-
of moving in the random way the points into sets, for example.
Okay.
There are different ways of achieving it. So it's just a matter of what you're looking for. But I'm just giving a bit, I'm trying to compress a bit of things with the surface
No,
and all of that. But great.
that's two great examples. Thank you.
Great.
How about
No
the
problem.
how about the width?
The width, yeah, here you can change the width in the radius when you in the all the cocoon components, you have the radius here. And the more that you change the radius for the smaller, it's going to be more intensive in the computational kind of expenditure. If you increase the radius, it's going to be less expensive because it's more like it's less resolution. So for example, if we put 5 here, it's gonna increase and put it more thick. If you put it 2, it's gonna be more thin, but also it's gonna be, then you can start playing with the cell size here. For example, if we put more cell size, it's gonna be less resolution, or if you put less size, it's gonna be more expensive computationally, but it's gonna be more connected because you have more resolution. So it's kind of a interplay of these values to achieve whatever the look that you're looking for here, like for example, this type of thing. So between the way that here the curve change chart, sorry, it's gonna control the radius, and this cocoon is gonna control kind of the resolution of the whole marching cubes, and then here the smoothness of the, once you have this, you smooth it, and it's gonna be like more as a more organic. It's gonna resemble more organic shape, and then you keep smoothing the surface, and then you have a really smooth thing. But yeah, you can play with all of these examples. Oh, that looks pretty cool in the chat, by the way. So yeah, I mean,
Yeah, it's a great logic. Thanks.
anyway, anytime. If you need, you can always write to me in the chat, and I can help you. Right now, if there are no other questions, I'm happy to answer any questions you have, by the way. So don't be shy about it. I'm gonna jump into a variation of this algorithm to produce similar shapes, but with another logic of growth. This is kind of a network of growth. This is the shortest walk, so that means it's like operating on a network, which give us kind of a hints of a logic of growth, or logic of operativity in the landscape. So how we can work with this. But then we can also have another logic of growth and something that's going to give us another type of results, which are pretty interesting. And we can keep using the same algorithm. So we can reuse these logics, like the production of the shapes with another input of logic. So I think it's pretty useful. For that, we're going to use some components from another plugin that is called Parakit. So Parakit is a series of components that have many usabilities. I like most of them. There's a lot of possibilities here for Parakit. You have that in the plugin folder that I uploaded. You have also like aggregation, and you have bunch of stuff that are pretty cool. You have like tilings, transformations. So there's a lot of things to play with here to have a lot of fun. I was interested for this workshop because we are dealing with this type of organic patterns and also to explore the options of growth algorithms and logics, to use Parakit and specifically this one of the components. We're gonna have another type of variation to do this, to also do this. This is also a bit similar to what we saw, but this is another type of branching. It's not like localized from one point to other points. It's just kind of something that is spreading all over the surface. And this is what acting as also with a set of points, with a surface as an input. The example provides like a vessel. So this is also pretty interesting because if we are working with specific construction or rational geometry, we can simulate something that is growing on top of it as a parasite. So for example, here if we input that, so we'll see how this uh, this component is producing all of this branching. The component doesn't have any other parameters, so this is pretty straightforward. That means that you have to play more with the inputs, the inputs and the amount of points, and maybe with the further logics of how you use the marching cube logic to give more of a look of a branch, of maybe kind of another type of resolution. So basically, what I did here, and this is easier than it's a variation, that's something that you can apply right away. You just, instead of here, I just input this vessel, and it gave me this branching. I just kept using the same stuff. Let's just turn this off a bit. And I also have here the way that we can animate this. So this also can be animated with the same logic that we were exploring last time with the slider. And basically using leveraging these branches, we can then use that and create our own surface curves here. Then I just kept the same configuration, and basically here right now this is pretty heavy. We can lower a bit the radius to have another type of logic. The cell size can be smaller also. It's gonna be more, yeah. So you see here that it's gonna be adapting more into the vessel scale. So if we put 0.8, for example, this is too small. 8, it's gonna start like resembling some sort of also coral reef type of structure. Oh, sorry. And then if we go and start smoothing that mesh, we'll have this type of formations, right? And all of these can be then smoothed out with the tab-move-large algorithm. So this is adapting to a specific vessel. You can do this also with the shortest walk, but I find this a bit more straightforward because it's less heavy. The shortest walk has plenty of processes behind it. This is really straightforward and it's producing already like this pattern of growth really like fast. If we animate this, it's gonna take a while because we are working with less with a really high resolution model, so it's gonna take a lot of time because the size of this vessel is quite small. But that's why I keep using this surface. Let's just erase this one. Just let's use this one and let's just stop this so we don't crash anything. And just feed here the surface. So if we feed the surface, we'll have on top of that surface also, let's just sorry. Okay. You have this pattern of growth and using these lines, which the output of these are basically just polylines or lines. And these lines are just yeah, simple lines. And with these lines, you don't need to call or remove the duplicates because these are unique lines. And I just create polylines and divide them. I could even, if you allowed me, I could even get rid of this to save a bit of, and just grab this and it's gonna be working already. So, and yeah, here we can use also a slider and have them a bit more interpolated, even though right now the interpolation is not making that much because they're just simple lines. For example, we could try to join these lines, join the curves. This is something that I didn't do before. This is something that I'm just trying right now to see what is that we get. And then we just graph them. We get this result, and then we're gonna get more curvy lines. So here we'll have this. It's gonna be more even like organic. And with this, we could even increase this a bit the resolution. So but let's keep it in 25. Which actually is gonna be the same amount of numbers here, right? That we want for our, sorry, just to test this. It's gonna change a bit. If you decrease that, it's gonna change a bit the smoothness of the curves. And using this curve, then we can create our cocoon. And then we're gonna have, right now it's quite big, so that may take a bit of time. I hope it doesn't crash because I reduce a lot of the values. So you see that it's pretty like linear. It looks like branches, but if we actually increase here the cell size, we decrease the ISO. Oh, ISO is okay. We don't. It's okay. Here the cell size is too big right now. not doing much. Let's go for 3. Maybe the radius, it can be higher. Whatever. Let's see if we put radius 2. So the whole thing is to play with these values to find something that helps to achieve our purpose to simulate this type of structures. Here, cell size could be smaller a bit, I believe. Maybe we can put 2, and it's gonna be a bit more heavy. Let's keep it in 3. So at the end, we're gonna smooth out this out with the smoother, and you see you have this type of shapes, and this type of shapes. Yeah, we can play also with these values, and these values will help us to reproduce the like the yeah. These shapes. So ideally, we would do, the cool thing about this is maybe you want to, maybe it's a heavy model. So that's why the cool thing with the animation is that you animate and exports the images, even if it's a heavy model, and then you can put the images together. It's gonna take time to export each image after each iteration of the model, but then you have the whole series, and then you can animate that. You won't be able, if it's heavy, to take like a video from the screen directly. So that's something that's why you have to kind of play and be aware of the values of the inputs, because they're gonna allow you to either run this faster or have other type of shapes or whatever you're looking for. But still you have the option to animate that with the slider, and you're gonna have each image as a reel, as a series of images, and then you just put it in Photoshop or any other type of software, and you can animate it. So yeah. So this was the organic pattern with the spanning tree. You can have that same example in the example folder, and you can just input the terrain. You just copy paste the terrain here that you had in the other example, and you just play with it, and you could like have really cool stuff here happening. You can change as we were doing before. You can change the height of this surface. You can like, we can try that. So let's see. We can input this surface. We just input this, and we just get it as a main generative shape here. Sorry, I always lose my full screen. So here, let's see what's the result. It's pretty fun to play and see afterwards. You see also kind of more distributed shapes in the set direction, and then smooth out, and then this is pretty cool actually. This can become some sort of like habitable structure that you can like inhabit here. So you already have some sort of if we change a bit the length here, we can have something like more like as an approximation. Sorry, we can output this. we can bake it. So no, bake it in the fall or something like that. And we put another type visualization. Sorry, artistic no. And we can have already something that resembles a bit and structure that we can inhabit, and we can, I don't know, we can input that into let's mesh. We can input that into the AI generator, diffusion image generator, and somehow have like some fast renderings from that, and it's pretty interesting. So huge possibilities, just applying all of these different type of algorithms. I'm sure pretty excited about this one. Cool. Thank you, Walter, because it's a great input to test, like to push the limits of this stuff.
Thomas, I have another question for you. Do you ever use multi-pipe?
Multi-pipe, what do you mean? Ah, like the component in
the yeah, so that you end up with sub-Ds?
Not really. I mean, I don't model that much. I do more like daily, in my daily basis. I work too much with like precision surfaces for like digital fabrication and all of that. These are the places where I get to explore other stuff in a fun way. But no, I never used the multi-pipes. I'm gonna give an example right now with a component that works also for multi-pipes. Maybe it's an old workflow that I found hidden in the obscure internet, but it's gonna be also some sort of it's gonna be part of that. So this is what we're gonna see here next. Oh, that's nice. Pretty cool. Is that with the multi-pipe?
That's using multi-pipe right after the minimum tree spacing.
That's pretty cool. That's pretty cool.
It's not there's not as much variation, but it's fast.
Yeah, it's fast, and it's also a surface. So it's more controllable. But yeah, I mean, their possibilities here are endless. So you can try any other post processing or post method after this, which is pretty interesting. Let's see. Then let's go for the next example. If there is another question from any of you, please just let me know that if you have any questions about this workflow that we just saw.
Sorry, I have a question.
Yes.
Sorry, I missed the name of the plugin that you used for this one.
Okay, this is Parakeet.
Is it in the folder? Because I cannot find it.
Yes, in the folder you can find it on the let's here you will find in the plugins you'll find shortest walk, measure, cocoon, flattern. Maybe I didn't include it, that's true, but maybe I didn't. It just skipped to put it into the folder. But nevertheless, let me just go here and look it up. Let's see the features, plugins. Oh, it should be there. Parakeet. Somehow I don't find it, but I'm just gonna drop it here.
Okay, thank you.
Yeah, with then Parakit is the one that you need. Good.
Yeah, thank you so much.
You have a lot of examples. If you go to the Food for Rhino webpage, and on the Parakit, you'll find like a really huge list of examples that the developers provided. So there you can test other type of stuff. So let's let's go with differential growth. This is also pretty interesting. It's also using Parakit, but let's just hide this one as well. And full screen. So here, okay, we still have our surface. Let's just bifocals here, so we can see all the names of the components. So, but anyways, you have already these components there. I think we don't need this one. And this is another plugin by Parakit that is called differential growth. It resembles a little bit the branching that we saw before, but this is acting more as a continuous curve. There's gonna be kind of adapting itself to a certain given boundary, and you can give any type of boundary. But I keep using this terrain. We can just change this terrain or modify it. And this is a bit different because it also produces polylines, like a complete polyline, but it is related to time. So you have to plug the time, this trigger that you will find in the parameters set. It's a timer, and this is gonna allow this component to run. Sometimes it's not clear how to do it. So if you have to take the trigger and just point to the component, it will accept it. Some components accept the trigger, some others don't. And then here you have a reset button. You have another type of inputs or parameters. You can test them, and ideally, this is what's gonna be. This is kind of the main input here. Is gonna be this polyline that is kind of a circle. And then if let's just stop this a bit. If we let it run, if we press play, then it's gonna start growing. And this is also pretty interesting. It behaves like this is really growing. This is a kind of animation, and it's just adding points, and there's like some sort of parameters driving these points so that they keep certain radius of separation. If you increase the radius of separation, it's gonna be bigger, and if you decrease it, it's gonna be smaller. So, and yeah, sometimes it's so you see this is driving that. And right, I just reset it, and depending of the inputs, it's gonna be more. It's gonna have more resolution or less resolution. So it can keep growing to the boundaries of the surface that you give it, and after stops, it's gonna provide you with a polyline curve. Here, this is already adapting to the surface, and after that, one of the examples was talking about this other component that is called flatten, and that's gonna allow you to increase to give it like this. You can use the marching algorithm, the marching cubes algorithms as well. This is like way straightforward. And after we were given this mesh, we provide as we want. For example, if we have this is the data. We have this data. Let's keep this data that we have here, and let's just internalize it and just copy it. And this is something also we can try this. This is something that I'm just improvising right now, and just to try what happens when we use the other workflow with this combination. Yeah, so depending on the values, then we can start working with the values. Here it became like a huge mass.
Wow.
But okay, we can work with the values here or with the values here. For example, this is more of a bigger, but depending of the values, we can have other type of patterns, and we can test it out. And we can test both of the workflows. This is what is giving me with the flatter. It's also there in the plugin folder. Just a component that's gonna give you this kind of shape. It looks like also like a coral or something. But you can put it in the other workflow, and it's gonna give you another type of shape. So you can use also this in combination. And these both are achieved with Parakit. So you have that to test. It's really easy, and the advantage of this is well, this you can see. Maybe if we can start if we I don't know, maybe change the amount, this size. Maybe it's gonna be too big. It's gonna give us something different. Yeah, here we have to test with the resolution of the line. If we decrease the size of the cell of the radius, it's gonna be really heavy, and it's gonna like break my computer. But if you want to try that in your own workflow with all your time, you can test it out. So for the purpose of these examples, I think I'm not gonna play with this that much. But yeah, you can see here this is another generation of patterns that you can try. And you can try it with this surface, or you can try with any other type of surface. It's gonna adapt itself as a growing pattern, as a with this differential growth algorithm. So yeah, I think it's pretty easy. Do you have any questions? Okay, so I think maybe we can. The next examples is it's gonna be a bit more complex. So maybe we make a quick pause, like I don't know, 10 minutes. Are you?
Yes, sounds good. This.
Yeah, we can do a small pause of 10 minutes, and then we come back to it. Okay.
Perfect. Okay. See you guys at 14:26. 25. Yes.
Great.
Bye-bye. We're coming soon. Great, Tomas. Okay,
So
yeah. Everybody's
let
here.
me just change a bit here the angle.
Okay, go for it, Tomas.
Great. So, okay, we saw, let's say, these algorithms that they dealt with growth. They're basically fueled by a single algorithm that moves points around and have a certain logic. Some of them, let's say, with simple inputs, and other the last one with like time based. So right now we're gonna go for something a bit more complex. So the build up is a bit more elaborated, and this is agent based algorithm. And I'm just gonna provide some uh, uh, initial inputs and how a bit the model is set up. This can vary a lot. There's a lot of examples for this, and there is a lot of plugins for this. I'm using one that is called Zebra. It's also in the plugin folder, and this is another kind of way of replicating some logic of dynamic appropriation of a territory, or certain relationships that agents can have with certain geometry or surface, which is pretty interesting. It's really interesting to have the ability to replicate and simulate stuff, and use all of these inputs as part of your setup of tools. So we are having the same surface, and here we will have a set of blocks that is gonna allows us to set up our model, or our agent-based model. And what an agent-based model does is just creates a class of model of an agent, an instance of an agent, as many as you want, depending of the amount of points that you input. And these agents will have a specific behavior. So this behavior is gonna also be parameterized for certain parameters that you can input, and the whole system is gonna live under a geometry, a set of boundaries. So these boundaries they can be different stuff. And also these behaviors can have also different goals. You can have the agent can have its own, let's say, parameters, how they behave next to each other. And they also can have a specific purpose. They can either go and follow a certain path. They can be attracted to a certain geometry, or they can be actually repelled by certain geometry. And you have this type of inputs for the whole model. And after you build up your model, then you can simulate all of these behaviors. It's gonna provide an emergence of shapes, and this is something that we are not gonna be in much control of the outcome, but we are gonna be in control of the whole boundary conditions of the model. So this is, let's say, unsupervised generative design. Let's say is lower control but more emergence, and the examples that we had before, they had more control, they were more discrete in the control, but you had certain limitations of emergence. You can predict more what you're gonna get. Here it's gonna be more unpredictable. It's gonna be depending of the setups. And for me, that's interesting to try also, to see what are the different possibilities. So let's go over it. So this part is mainly geometry. This is the geometry part. We have the terrain. Still, we're gonna input a path that's gonna be let's say our in this example, it's gonna be a path where the agents are gonna be flying. So
Thomas?
yes.
Thomas, which of the files that you gave us are you working on? Yours says agents, and you gave us agents flowing and agents attractors.
It should be there. Oh, maybe let's open agents flowing, because this is yeah, let's open this one. Okay, flowing path, right? Yeah, it's basically the same. But the one that was kind of the basis of all of them. So it's just this file has this curve reference to the definition. In this definition, what I do is just take this line that is like floating over the terrain. I just project the line to the terrain. So we have kind of a line that is really attached to the actual geometry of the terrain. And I move this line a bit up. And so you see here that the line, after it's projected, is being moved up instead in the C coordinate. So you have this like path that is resembling the shape of the surface. I'm sorry. Excuse me. I have to open the door for my wife that is knocking the door. Give me a minute. Estamos aquí. A ver, sorry for that. I'm back. I should have asked my son that just arrived. Okay, so here we have this curve, and this curve is gonna serve us for first defining the point of departure of the agents. Point of departure of the agents is gonna be just gonna get rid of this. It's gonna be a plane that's gonna be at the beginning of this curve, perpendicular to the curve. And then there, I just created a circle that is then turned into a surface, and I just populated that surface with a random set of points. Also, that line is gonna give us the ability to create some sort of a tunnel. It's gonna be like a pipe. And this pipe is gonna work as a container of the agents. So the agents are gonna be like flying, and they're gonna be contained by this pipe during their path. So basically, what we do is we have the way of creating the agents. We have here we have an agent that this is we can see it here. Let's just put the bifocals again. Do you see the name of the components? Thank you for the suggestion in the chat. So you see here, you have a set of agents that they plug in 2D. You have a set of agents that they plug in 3D. There's another type of agents they plug in a surface as well. So we can create different type of agents, and they will have a minimum velocity and maximum velocity, and a starting point. And my starting point is gonna be this like random points that I created here in the search curve. Actually, it's this one because I moved it up. And here are my agents, and this is the point of departure. and they're gonna be constrained to this tunnel. So basically, they're gonna travel along this pipe. So after I created my agents, I set up the maximum minimum the velocity. I have parameters for the agents. This is another component. Also, you will find it here in the Zebra menu. And here you have different types of parameters. You can try them. You can test and play with them. And here you find like how they can be separated. They can just travel next to each other, but they can separate themselves, and depending of their path, they're gonna be moving. They're gonna have also cohesion, alignment. They have a lot of time parameters here. Then we're gonna have the behavior. You could have several types of behaviors. You can have attraction. You can follow a path. You can have a repulsion or repelling behavior, and you can attract. A line can attract all the agents and so on. So you have all of this here. Also, if you go to the Zebra grasshopper in the grasshopper food for Rhino, you have there a series of test files, and you can try all of this. And also, it has a lot of tutorials in YouTube, so it's pretty useful. Then you have here the containers. You have here the box container. You have a breadth container, and you have a mesh container. Also, there's a surface container. It's gonna allow the agents like travel through a surface. In this case, we're gonna use the breadth container, and my breadth is gonna be this breadth, the pipe that I created with that project line. So after all of that, then we assemble our model and our solver. That is, this plugin engine is gonna solve the model. It works if you've worked with Kangaroo or one of these things, it's gonna be really similar. And then let's just open, and I'm just gonna turn on all the stuff that we want to see. Here's this one. Maybe we want to see another pipe now. Let's just keep the agents. Okay. So in here you have then the agents. You feed the agents here. You feed the flocking properties. You feed the behaviors, and you feed the containers. And then here you have the reset button, and then you have the play, let's say the trigger. Here is this is parallel computing from Grasshopper, so it's turned true as a default. And this is a faster method to calculate flocking. I don't know what is it all about, but it's also turned true as a default. So basically here you already have you have the agents ready. And then if we just press play, they're gonna start moving. They should move, sorry. Yeah, they start moving. So they move along. Let's just turn this off so you will see. They just move along this pipe that I created. And because it's separated from the terrain, it resembles that they are like responding, and they're flying on top of the terrain, and they're responding to the actual shape of the terrain, which is a pretty cool effect. So they look like a flock of birds or something that are flocking together towards and then they just stop there because this is their path. So with all of these, you'll be left with a bunch of points. In this case, we have 700 points. And if we use the same technique as before, then we have the ability to recreate these points in the path also with the animation tool, with the slider. And then we can create some sort of animation of a flocking event or something. We can attach some polylines, and you can have also polylines created from these points. And depending of the height of the thickness of the tube, maybe the parameters that we give it. For example, if we can clear this out and we can change a bit the parameters. Maybe we can increase the separation and separation distance. We can decrease the cohesion so they don't travel so together. So basically, let's try it to see how it looks. Just clear this out, reset this. Okay. Here you see the things ready, and they just start traveling. And because now they are behaving differently. I believe you can even, if you want to control a bit more you can give it less velocity. So they travel a bit slower. So you can control a bit more these parameters in the resolution, so they're gonna be separate them. You can join them to see how they change while you move these things around. You less cohesion, so they start also behaving differently. You can spread this thing, and just they're gonna open up. So this is something that you can actually like jam it. Also, it's something that you can start improvising, and all of these parameters are gonna give you different type of results here. You see, and this is quite interesting to try as also as part of a landscape, because you have the ability to create this type of containers that they can be developed as you want from any geometry. You can just make them flow and fly whatever, like in any type of form that you want. So this is, for me, is a pretty cool tool to also simulate stuff. And then you can control here the sorry. Okay, you can control you can regenerate the flight again. This is actually pretty cool to have this type of change of patterns here. So this is one set of simulations that you can have. Do you have any questions about this? Here we can have these multi-pipes also. Here we can have we can like use these lines to do several stuff. We can project these lines also on the surface again if we want, and we'll have like a path drawn on the terrain, and so you can be really creative with this. And yeah, there's plenty of possibilities, and it's also something that you can then like play with it while it's being executed. Cool. Let's try to do the other one that is is a plugin for attractors. I say try because I don't know if it's something from the from plugin or a bug, but let's see right now how attractors behave. So in this sense, we're gonna build up also. We have the same agents, but we can set a point of attraction in the topography with the same technique that we used before, using evaluate surface. And we use the MD slider. We reparameterize the surface here. So we input this, and then we'll have a point that we can move around. So we can move around this point along our surface. And then we can create an attraction geometry that we're gonna use for the attraction behavior. And instead of having the flowing behavior, we're gonna add the attraction behavior. So what we can do here, this is something I'm gonna try. This is sometimes, let's just, okay, great. Let's try this out to see what it looks like. And let's increase a bit the velocity. So you see already the agents, they're traveling across the pipe that we set because the pipe is still there. But I think they're trying to reach this point because it's an attractor. You see, when they just approach this circle, they just stay there because this is where they want to. This is where they want to be. So they stay there. So we could play with this. We could, for example, we could change the origin of the points. And let's stop this thing. Instead of having the points created in this circle, we could have the points created in the surface. This is the surface that I want to achieve. Sorry. Yeah. You can just reset this. And you'll see that they're gonna try to reach that point. Now they're reaching the line. This is the attraction line. So they are behaving. They're trying to reach this attraction point. That is basically the circle. This circle is this is the attraction point, and they are trying to reach it, keeping themselves inside of this pipe. So if we reset this, you'll see how they try to get into a pipe. And they just try to reach that point using that pipe as a set of input. That means that if we change the curve that is giving the pipe its shape, they're gonna change their behavior and they're gonna reach this thing from a different path. And they're gonna follow this path. So this is also a really nice way of creating kind of a growth simulation. So here, using our sliders, we can recreate this thing. We can even reverse it. Oh, this is not, whatever. Yeah, we can reverse it. And we can, instead of going from out, we can be going from in to out. So it can be kind of something that is trying to reach a certain, like from a center to the outskirts, or the inverse. But the important thing is that you have the data to create, to replicate the phenomenon, and that gives you a lot of advantages. This can then create several lines. You have to be careful if you want to take this into the other workflows, because in this case, you'll see here that you reach a point where you have a lot of accumulations of lines. And if you input that into the marching cubes, that could be too much lines to process, so it can crash. But this is a way of generating this thing. Also, interesting, we can have different type of breps as a as a as an input. So you can have boxes, you can have meshes. Also, here's a mesh component. There is this other attractor, just gonna the one that is working on the surface here. Oh, sorry. And this is working on this surface. Okay, this is another surface. It's not the surface that I'm currently using, because at some point this is something that we have to test better. I don't know if this is a bug. Once I put my surface, it doesn't behave properly the way that I want. But if you use this surface, the agents, they just act on top of that surface, and they just constrain themselves to act in this surface. So you can have also create kind of like a network of points there using the agents, and depending on the behavior that you assign, you can have this point as a attraction point where everyone is gonna try to reach there. You have the repulsion one, so they start trying to avoid it, but yeah, you have to map that better. You have another behaviors. They try to follow a line, so they try to reach a specific line. And yeah, you can test a lot of all of these other behaviors. It's cool that this is, you can set you can think this as a emergence system. So this is nice because you can jam with it. You can change the parameters. What is happening is going to change. So you have some sort of control on the behaviors, but you don't have an actual saying of what is going to be the last result. So for me, that's quite interesting because it's always unpredictable. But you have certain parameters that you can like steer these systems into it. So I believe these systems can be expanded by like points right now are generated randomly, but if you have a specific coordinates of I don't know, points of interest or coordinates that you identify as important as like source of certain data, certain I don't know, behaviors, agents in your cases, you can just map that and use these systems to replicate or simulate other type of outcomes, or maybe try to reach the same outcome and kind of do kind of a empiric test here. So I think this extension of methods is pretty interesting, as also as a design tool. You'll find plenty of other examples of how this can be applied in the Zebra YouTube channel. There's plenty of other agent-based systems for Grasshopper. This is, I think, a really nice one because it's really easy and it has a lot of documentation. There are other ones which they don't have that many documentations, but yeah, here you have it and you just can test it. And all of these examples are already set up. You can change the values and whatever you want. Okay. Is there any other question?
Thomas, when you toggle true and the agents start moving,
yeah,
is there a way? What's the best way to slow that down? Because they're kind of really fast.
Yeah, here you have it in the agent parameters. You have max mean velocity and max velocity, minimum velocity and max velocity. So you can decrease that. So they let's move it in the other ones that are, I think is easier. Yeah, here I'm flowing. Here you can change this. It's gonna decrease the velocity. So whenever you hit, if we clear this, and if you hit play, right now they're really slow. But yeah, you see they start going slower. So you can control that here in the velocity of the flocking agents. Yeah, and then here you can start like playing with these things, and they'll start moving. Pretty cool. Actually, time step also it increases the step of distance between each step of the travel. So maybe you can play with this as well. So here you see that here the distances between the points are more where are the points here? So it will allow you to have like a bit less dense lines maybe. But yeah, this depends of what you want to achieve. But yeah, you have all of these options. You can then control the time step that's gonna give you, it's gonna be faster, but the separation of agents is gonna be greater. If you decrease it, it's gonna be slower. Separation of agents is gonna be smaller, but the velocity isn't gonna increase the movement of the flocking. So you can play with these two values to reach whatever velocity you want. But then you can, if you want to rebuild your simulation, that you just can release, you can how you say it, like you can yeah, sorry. You can rebuild your simulation with the points here with the slider. And also you can control a bit also the velocity of your final visualization if you want. I hope that answers your question. Is there any other questions about this? Okay, great. Well, I think that was all that was planned for today. Alejandro, you will confirm that with me. And if you have some comment, Alejandro, to expand the session, or give some input over what you've seen today.
Well, fantastic. I was thinking that was great, Tomas, and very nice interactions for some of you guys. So I can feel that many of them are in their way, in their path. So if you have any doubts, guys, maybe you can email Tomas.
Yeah,
His
definitely.
contact is there in the document. He will join us, of course, in certain point the following days, especially in the last day. And I just want to suggest to pick up some of the tools that Tomas has been trying, especially we put in our outputs the animation, the behavioral or the growing logics of some of the species that you are working with, especially the ones that Tomas provide you guys, and to test slide them and try to see how they grow, and especially if you can make some simulations of the growing systems to use it as a videos or stop motions, something that have been recurrent or repeated in different cases from Tomas is the possibility to add it to a landscape or to a geographical or to a ground surface that is make it the exercise very, very much interesting. And as he said, you can see, for instance, this image that he's showing now, how they could be fitted the algorithm in the session of tomorrow. Maybe it could be very simple images from you, not necessarily to be rendered, maybe something like that, as he's showing now. Could be a print screen and then added in Midjourney or in Crea, and let's say speculate or add as in a prompt certain qualities to the image that you want to produce. So, but something that is exciting is that connection, something that we have been really trying in previous seminars in the master studio. And we can see that our students, the one that match geographical or topographical conditions or ground conditions with the performance of some of these organisms are really produce images that allow us to inhabit the space of the microscopic world. So try to find that. It's about to set up the right perspective and then get outputs from that either as a stop motion or as a still image to then feed it the algorithm tomorrow with the image generation, the AI image generation, right? So I think even some of this image, I would think in Tomas and Rebe that could be also, you know, it's not necessary to render. I mean, this system of dots or points also could be interesting way to imagine the microscopic world, no? That from its own structural condition, that it could be also, you are allowed to do that, not necessarily to be rendered, but maybe to slide the compositional lines or structural lines that the algorithm content and slide them to see how they perform and they react, and that could be also exciting to see how the AI image generation interpret either Midjourney or the other softwares that we're going to use tomorrow.
I think that like the difference when there's this huge now like development, and there's this huge step forward, because before we will have to create the algorithm, we will have to generate the shape, we'll have to make sure that the geometry will be healthy enough to map it, and then we'll have to visualize it with a render engine or whatever, and that takes a lot of time. If you had like an automatic workflow of that, you will have to know each step of that and control a lot of parameters to have a really nice image. I think the difference now is that we can just have a really rough generation of a geometry, of an effect, and then we can feed that directly into the diffusion model. And the diffusion model is going to help us to provide a preliminary like image that we can already anticipate. We don't have to like produce all of like do the pre and post production of all of these steps to get an image. finalized image or something that is gonna approach to our uh, like whatever we have in mind. And it's not only that, it's also gonna interpolate other possibilities. So this increases our workflow in such a massive way. In it gives so much value to our work, and then we can just keep all of these like really really they're really laborious steps, you know, of handling all of these different parameters in all of these type of software. One that does the geometry, the other one that maps, the other one that renders, and you have to know all of these steps. And now with the diffusion models, you just can give already a really approximation of an image that you want. So I think it's just increasing the speed of all of this, and it's just providing us with a lot of nice feedback of our work. And I think that's the point.
I think it's a very relevant point, Tomas. So nice that you said that. To soften the process of this kind of a hyper reality obsession that we always look in, or we always the digital world trying to produce, no?
Yeah, definitely.
But instead to be able to test other forms of representation, no? that also produce the same experience, or even amplify the logics that not necessarily we need to see it because it's hyper real. You have the possibility to render tomorrow in a different forms of representation. So yes, could be hyper realistic, could be illustration, could be diagrammatic, but it's interesting also to post edit or have certain ways that you can see the wireframes or the structural lines, and then you add textures in some others. So that give us a more integral way to imagine the microscopic world, right? So even the pattern behind, or the geometrical patterns behind what we are seeing is also sometimes even more revealing than to see the microorganism itself, or to see in the lines or the flows that they project is also interesting. Okay, so thinking that, keep your mind open, work a little bit with the aesthetic of the accident, or the aesthetic of the imprecision, or the aesthetic of the, you know, the trials, the testing spirit that this process has, and believe in those image raw, that they are more expressive because they really show conditions that they are quite behavioral or structural, right? So we like to flexibilize the process and liberate you from that pressure.
Yeah.
Encourage your abstract thinking through the tools. Very nice sessions today. Thank you so much, Tomas.
Anytime, as Alejandro said, if you have any other questions, just write me an email. Try to answer your questions, help you out. And well, I hope you enjoyed, and I hope this was useful for all of you. And you have all the examples there. You just start playing with them and have fun.
So I was seeing if so. Okay, we are under 5. I know that some of you have been working in your presentation. For instance, Nastar, and we were talking to seeing you at the end of the day. I can see that you also are working now in this. You are quite exciting, asking questions. If it's okay for you guys, we would really like give you the space to produce, because you're having a very rich days and dense days, and I know that you have been trying to put together some of the exercise that Rebecca and me was talking in the morning. So please go through the instructions that Rebecca pastes in the document, and give it an attempt. Right, it's always given a second chance, a second attempt, and we would like to see you tomorrow for pushing forward your conceptual approach and your research approach, as well as enjoy the session that Aram has been preparing for you in continuity with what Tomas explained today. All right. Bebe, you want to mention something? Yes.
And this video will be available also as a resource to come back to in the YouTube channel that we have for this workshop. I can paste the link here in the chat. So yeah, so we can just rewatch it and try to apply all of these tools to whatever we are trying to visualize. So it will be in a YouTube channel. I will put it here as in the chat.
Fantastic. So there is one more thing is that very much related with something that Tomas was mentioning in relation with the kind of algorithm that he selected for the session today. They are representing the organic growth. It's true that it maybe is not exactly the kind of species that you are working with, but doesn't matter. So I think that tomorrow we can be more speculative in that sense, or you can find a way to instrumentalize this algorithm into your own research. But use it freely, despite the fact that it's not exactly the species that you are working with. And please have a look of the document that we provide in Word, where we specify some of the species of the Arctic that we are working, that are related with the samples that you have in the folder. Go to the folders and use it and select go to this Word document and try to read about and highlight the parts that you consider better to bring it back into a paragraph that is this synopsis or this previous prompt for tomorrow, combining with your historical background, the kind of species that you want to work with. And if you do that, if you have that very much this first idea for the prompt for tomorrow, what we call a synopsis today or abstract, reading this document, you will extract some species as well as you can find the species specificities of the species in ChatGPT or in Google or Googling. Download images that you think that is important, and please use the image of the microscopic samples that we place for each case for you, okay? So prepare some of this information in your Miro board or in your PDF or Word document, and let's be prepared for tomorrow for the session of AI image generation. It was very exciting today again, guys, and thank you so much for the spirit. Thank you so much, Tomas, for such an amazing insight.
Thanks a lot. It was great.
Okay, have a nice weekend, guys, and nice to see you. Thank you for this opportunity, Alejandro, and well, I'm really excited to see the result of these works on Sunday, right?
Yes,
Yes.
exactly. Okay, we see you very
I'm
soon,
really looking
Tomas.
forward. Great.
It was amazing. Thank you so much.
Anytime. Okay, take care,
Okay,
guys.
guys. All right, have a great day. See you tomorrow. Good luck.
Bye.
And
Keep aspiring. All right.